All right. So we did that. We did this. Okay. How are we doing? We're doing good. We're doing good. So what are we doing? We are learning how to use the abacus. Here's the abacus. It's funny. I can't believe how crazy it is. Posted. Okay. Welcome everybody. Welcome. What are we going to do? What are we doing? We are learning how to read the abacus. When we learn how to read the abacus, we need to understand. There we go. Ah, that worked out very well. Cool. So we're going to read 1, 2, 3, 4. Now, if you notice, these are the beads. This is the beads of an abacus. The abacus. Ooh, sorry. Oh, what's going on? Okay, cancel. The abacus is a way to count. Why are we counting on the abacus? I already know how to count. That's okay. That's okay. We can learn how to count different ways. 1, 2, 3, 4. Notice the beads. Ooh, that's not right. There we go. There we go. So 1, 2, 3, 4. All the beads touching this horizontal bar is being counted. So because it's being counted, this is what we call the horizontal bar. So this would be 5 no matter what. This will always be 5. Now, when we look, we're looking to see why are we doing this? We're doing this because it's fun. So what are we going to do? We're counting on the abacus. The abacus is a math counting tool, just like we use, like, I don't know, we use the dot things. There's blocks. There's these blocks that we use, um, math blocks. Oh, maybe I should get some math blocks. And so it's kind of like, using the abacus or using these math blocks. But I think the math blocks is a little bit more unruly. The reason why is because it takes a while to manage. Okay, so what are we doing? We're going to be counting on the abacus. Now, if you notice, we have 1, 2, 3, 4. That's 4. Well, people are like, well, why are we using the abacus? Well, it's the same thing. Why are we using these blocks? Am I being salty? Yeah, I'm being a little salty. I should stop. Okay. So, what are we doing? We're counting. 1, 2, 3, 4. Counting on the abacus is just one of those things. This is a math learning tool. This tool helps us see what the numbers are. So, this is 4 because the beads that are touching the horizontal bar is. This is a horizontal bar. This is now being counted. Because this is being counted, this is understanding that this is 5. Because this is 5, we have 6, 7, 8, 9. Well, if you look, I have 1. And then when I add the 5, now we have 6. When we have 2 and we add the 5, now we have 7. If I have 3, right, we have 3 and we have the 5. Oh, I don't have it here. Now we have, add 5, now we have 8. So when we are looking, thank you so much for liking the live. So what we're doing is we're counting on the abacus. Counting on the abacus um, it's a math tool, and we can actually do adding, subtracting, multiplying, and dividing. Um, it depends on how far we go, but for the most part, it depends on what? It depends on energy level. Ah, here it is. So when we're doing 5, right? This is 5. 5 is the top bead. So that's what 5 is. Because this is 5, that's the top. So we have 6. How do I know? Because we count from 5 and then we have 6. So we have 5, 6. That's the number 6. When we have 7, this is what 7 looks like. Notice I'm using this dot right here. This dot right here tells me that this is the ones place. Because this is the ones, this is where I'm going to start. So when we can count 7 and then 8. This is 8. And then after 8 is 9. Thank you guys so much for the hearts. Thank you so much for the hearts. Let me know if you have any questions, but I'm just counting right now. I'm just counting to show you how easy it is to read the abacus. And so when we look, this is 10. When this is 10, how is this 10? Well, we have our ones. This is 0 and this is 1. So this is 10. When we look, we have 11. After 11, this is 12. After 12 is 13. Does that make sense? So we count whatever the beads are touching this horizontal bar. When the beads are touching the horizontal bar, this is now being counted. So these columns over here, they're not being counted. They are just zeros. So the question would be, well, what happens when we have this? Well, this is 18. How do I know this is 18? Because we have 5. I'm sorry, this is 5, 6, 7, 8. And then this is 1. So this is now considered 18. Well, why am I here? Because I'm here because this is my ones indicator. Just how we have when we write. When we write our numbers. We have our ones, our tens, our hundreds, our thousands, our 10,000. And so what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, then we can go into adding, subtracting, multiplying, and dividing. So hello, Maggie and Dadicus, Dan and Anna. Let me know if you have any questions. Thank you so much for the hearts. So what we're doing is we're counting on the abacus. We have 1, 2, 3, 4, and then 5. Because this is 5, we have 6, 7, 8, 9, and then we have 10. Now we can count by tens. 10, 20, 30, 40, and then 50. After 50 is 60. How do I know? Because we have a 5 and a 6. 5 and 1. 5 plus 1 is 6, and then 7. 5 plus 2 is 7, and then 8. 5 plus 3 is 8, and then 9. 5 plus 4 is 9. Let me know if you have any questions. We're going to continue to count until there's somebody here. So we have ones, tens, hundreds, thousands, 10,000. When we look, we can count by hundreds now. This is 100, 200, 300, 400, and then we have 500. 500, 600, 700, 800, 900. So when I look, this is 900. How do I know? Because this is 009. Every top bead has a value of 5. Thank you so much, Maggie. Let me know if you have any questions because I think you're the only one here. Let me know if you have any questions. What we're doing is we're just learning how to read the abacus. After we learn how to read the abacus, we will go into adding, subtracting, multiplication, division. But let me know. Let me know what you want. Let me know. You know what? We can do numbers. We can do numbers. So if I had this number, this is 1,952. So yes, the 5 will always be the top bead. Multiplying, hey, jump. This is, yes. So these are all the values of 5. When this is the value of 5, then you count, then you can count after 5 is 6. So I'm going to clear my abacus, and when I count, I do 5, 6. And then if I did it again, this is 5, 6, 7. 5 and 6, 7. And then if I did this, this is 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. But if I remove it, if you notice, I have there's no more top bead, there's no more 5, then this is considered 4. Because all the lower beads has a value of 4. 1, 2, 3, 4. And then if I did this, this is 3. 1, 2, 3. Yes, jump, multiplying. No, we're not multiplying right now. What we're doing is we're reading the abacus. Let's first how to read the abacus, and then afterwards we can start going into adding and subtracting. So, Anna, your name has 276. To show that on the abacus, I have 2, 7, and then 6. That's what that looks like. Why? Oh, you know what? Exactly. That's a very good question. The reason why is because I have this dot indicator. This helps me label where my ones place is. You could choose this one, you could choose that one. It doesn't really matter, but you just need to choose one like a Pokemon. So my Pikachu likes to sit here. The reason why is then I have a lot more digits. If I did this one, then I would have to move everything over. This would be my ones, my tens, and then I would have no more hundreds. So that's why I chose this one over here. It doesn't really matter which one you choose. But then like if you had a bigger one, oh, then some people say that I'm colorblind. I don't know what's going on. Well, it's okay that you're colorblind because you can get an abacus that is a single color. And it actually has nothing to do with the colors. What it has to do is the positioning of the beads. So when you look, if I'm going to match it up, I have my ones indicator here. I have my ones indicator here. So I'm trying to match it up. When I match it up, you'll notice it works exactly the same. So this is 1 and 1, 2 and 2, 3 and 3, 4 and 4. And then 5 is the top bead. The top bead comes down, and that's what being tracked on the horizontal bar. Thank you guys so much for the hearts. So what's going to happen is when you track it, right, with the with the horizontal bar, this is 5. And then we do 6, and then we do 7, right? 5, 6, 7. This is 7. If you notice, these two beads that are touching the horizontal bar is now 7. And then we have 8, and then we have 8. And then finally we have 9, and then 9. So the question goes back to why are we choosing the one over here? It's just because it's got bigger numbers. So if I chose this one to be my ones, then I'll have all of this 13 columns. I have all of this as my digit. So when I look at it, I can do my ones, and if you'll notice, every dot is at a group separation. So my dot, ones, thousands, millions, billions, and trillions. But what happens if you want to track the national debt? Well, 13 columns is not enough for the national debt, right? So you would have to move upgrade, and because size matters, you would have to go to 23 columns. So the 23 columns, you'll be able to track the national debt with not a problem. All right. So that was the question. Yeah. Any other questions? Those are really great questions. Thank you so much for asking. Let me know if you have any more questions. We can continue on. Oh, so these ones are made out of plastic and they work exactly the same, right? These work exactly the same as this one. This one is made out of bamboo, and I've been teaching for abacus for about 20 plus years. So that's why I had this one for a while, and then they came out with these ones. But they work exactly the same. And then if you notice, they're very, yeah, not a problem. Thank you, Anna. How do you multiply? How did you come up with the abacus? I didn't come up with the abacus. This is a very old, ancient tool that we learn, and it is being utilized in everywhere around the world except for America. Yeah. So these ones is made out of plastic, and if you notice, they're very easy to move. And then because they're very easy to move, you should hold it so you can. How did you how did it take for you to learn it? I was forced by my dad because he wanted to open up a learning center, and he's like, "You're going to learn how to read the abacus." And I'm like, "Why? I don't know why." And he's like, "You're going to do it so we can have a business." And I'm like, "Ah." So that was the reason why. In Mexico, no, this one's made out of Japan. This one's made out of China. This one's definitely Japanese, and this is a very popular Japanese um, soroban manufacturer. Tomo, very expensive too. Not extremely expensive. It's like this is like 20 to $25 at the time. You might see it for $50 now, but it's very delicate. The um the craftsmanship on this is very interesting. So, but yeah, it's not in Mexico. I'm asking if these are used in Mexico. I don't know if it's used in Mexico. I don't know. I know some people in India. I know a few people in Africa, Ghana. I know some people in Malaysia, Taiwan, China, Japan. There's a whole video. I don't know. Yeah, thanks. I mean, it doesn't hurt to try. So, the question, so I learned how to use the abacus when I was 30, and oh, it's been a little bit, but my boys know it and they are pretty confident with their numbers. And so, hello, Mr. M. Good morning. Good morning. Good morning. Yeah, very cool. I think you're a tree trunk. So yeah, no, I mean it's available for anybody. It just it depends on where the information comes from, right? So yeah, I mean they can use it. There's no cultural problems with it, but it is mostly Asian. But the mainstream math system is very Eurocentric. Ever wonder why the U.S. stopped using it? The U.S. I don't think ever embraced it, to tell you the truth, because I think the problem was, if we can philosophize, I think the problem was there was no connection to why are we using the abacus and why are we using like um, numbers and so forth. So what I'm trying to say is we have these things we call formulas. These are like what we're using in school. What are these called? These are called number additions or whatever. These are called, I don't know what they're called, math facts. They're called math facts, but in abacus we don't use it this way. We actually manipulate it. Yeah. No, it's not because we're lazy. I think because the mainstream math is very Eurocentric, and so it's very much like they didn't want nobody really wanted to understand how to relate abacus to mainstream math. I don't think it's laziness, because there's a lot of people that really creative with their math. Number bonds. Yeah, exactly. So you're right. We do the number bonds, right? We do this, but then that's as far as it goes. And then there's the whole making of the 10. I want to make a 10, right? 8 and then 2. But it goes further. So in abacus, we actually do distributive property. but distributive property. We actually use distributive property, but nobody in the abacus world talked about it because we don't label things like that. If that makes sense. So there's a lot of things that abacus does that we do internally that nobody has labeled. So some of it is distributive property. Another one is called, what's the other one? Oh, we don't talk about partial quotient. We don't talk. Hey, Enrique, you're back. Can we test and see how quickly you can add? Let me test you and see how quickly you can read my numbers. Enrique was here yesterday night, and he was like, "I want to know." And it's like, "I Enrique, I talked about adding and subtracting last night, and you were gone already." I articulate the wait, I'm sorry. I articulate it as implicit learning versus explicit learning. Okay. You know, I don't know. I mean, if you really think about it, we do have a lot of manipulative. I only have a few, but we do have a lot of manipulatives. And so why are we using this as opposed to this? Yeah, Enrique, am I boring? I didn't mean to make you fall asleep. I'm sorry I put you to sleep. Was it a nice sleep? I hope it was a nice sleep. Oh no. I'm kidding. I'm kidding. As hey, you know what, Enrique? As long as my voice was soothing and it put you to sleep, that was the best. Okay. So wait, I'm sorry. Going back, I don't know. I think a lot of it is the terminologies. I think the term we don't use a lot of the terminologies in abacus world. So that's what I'm trying to do is I'm trying to relate everything that we do in mainstream math is what we're trying to do in abacus world. And so I do a distinction between what we do in abacus world and what we do in mainstream. And so it was one of those things like I just think that there's not a lot of connections. Oh yeah. Okay, cool. Movement versus terminology. You know what? You know what? I don't know why visualize we try to get the kids to understand this. These are 100 blocks, right? But this is still very much paper. Thinking out loud. No, hey, Mr. Clean, welcome back. No, I understand. This is really good conversation. So I was thinking about this. Like I was thinking about this. In school, they use goldfish, and when it's food, teaching them to play with their food, basically. But that's the other thing, right? Like we teach them how to do this. We also teach how to do the number lines, and that's fine. But this is still so we still have the number lines. But if you look at the number lines, it's still very much a picture, but we don't take it to the next. We don't use the concrete, and I don't understand why. Like even with the Macala that you were using, right? They don't use this is a lot of management to work with, right? So this is like tough. And so it doesn't to me it doesn't translate. I don't know why I don't know why mainstream math has not embraced the actual concept of abacus, which I don't understand. Because we're going back to the whole was it concrete, representational, and abstract. So abstract is the numbers. Now we're just philosophizing because it works. It doesn't work because you know what? In school we were taught to memorize, and I think the problem was we were just the best thing was to just keep memorizing as opposed to understanding why. So one thing was to in abacus world we understand why are we using the numbers, whereas in mainstream they're going away from memorizing, right? We go from adding like what adding doing strategies like learning your doubles, and then they're going into like, well, how do you make an eight? And it's like, no, 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 instead of focusing on the result, focus on the add-in. So I think it's a little bit it's also a little bit of a mind shift if you think about it, because when we talk about simple addition, right, they still focus on the result, and I don't know why. They say, let's make an 8. I was like, wait, what? Many schools don't use it because it works. Oh, many schools do not use it because it works. Hmm. Ah, Mr. Clean, I love when you're teaching. You're very passionate, enthusiastic when you teach. Yeah, sometimes institution can be backwards. Yeah, in the yeah institution, but this is like a whole thing for me. I really go off on a rant on this, and I I get a little salty because we have all these other math manipulatives, but we don't nobody wants to learn what this is. And I think that's a cultural thing too. Like, oh, this is like a woo woo Asian thing that we don't want to touch. But I think we just if we can Americanize the abacus, which is what I'm trying to do, I think it'll be fine. And in I'm not to say like all the videos that we have on YouTube, they're very much with an accent, right? Whereas there's not very many people who have no accents, like an American accent, right? That will actually teach. And so I'm here to spread the good word of abacus. Thank you, Mr. Clean. I do find that abacus is the gateway to complex math. And if you can hands down understand this part, then it will work out well when you get to more higher complex math, because then you don't need to utilize brain power to do adding and subtracting. You just have to use the mill. So I'm sorry, if use it if I could understand it. Okay, yeah, you're right, we should start talking about it. I like to philosophize about math. And so when we talk about it, thank you, Ruth, we're going to do it. We're going to talk about one. So the first thing we're going to do is we're going to understand how to read the abacus. When we understand how to read the abacus, we go 1, 2, 3, 4, and then we have the value of 4 touching the horizontal bar. Because the bar is being counted, because the bar is being counted, is using to count. When I do this, this is now 0. Because this is 0, I can now add 5. The top bead will always be 5. So we have 5, we have 6, right? How do I know? Because we have 5 and we have 6. 1 is at the bottom. So we have 5 and 6. So notice this is 1. If I have 2 and I add the top bead, now we have 7. If I have 3 and I have the top bead and I add it, now we have 8. If I have 4, this is 4, and I add the top bead, now we have 9. Thank you, Ruth. Let me know if that makes sense to you. But I appreciate it. Yeah, I need to get back on without ranting about the school system. So we have 9. So if you notice, this is 9. This is 9, 9, 9, 9, 9. So these are all nines. When we look, this is all 0. When I do this, this is 6. Now, if I did this, this is 26. How do you know that's 26? Because every column is a place value. Does that make sense? You're the only one. Yeah. Anybody else? Thank you for the follow, Ruth. Even though I was ranting about school. So yeah, what we're doing is we're trying to learn how to read the abacus. And when we're doing this, right, we understand that every column is a place value. So, right? And it's super easy. So it's ones, tens, hundred thousands, 10,000. Mr. Clean. Yes, Mr. Clean. Thank you. When we look, we have 500. We have 526. And then when we look at it, we have 0. These are all zeros. Now, when we add, notice when we add, we're going to be talking about the add-in. Focus on the add-in and not the result. What does that mean? Well, we don't need to learn our doubles. What we need to do is we need to understand how to add the 1. I'm getting it because of the rant and it's all the my rant. Really? Is that my hook? Hey, Bella, welcome back. Ruth. Oh, so is that what it is? I should rant about the school system. Okay. Whew, okay. So what we're gonna do, and notice what we're gonna do is we're gonna focus on the add-in. So why are we doing it? The reason why is because sometimes in the abacus world we get the rant mode. I'm sorry, really, the rant made me click too. Actually, really, I'm a mother of 3, and I felt it in my soul. You know, I am a mother of 3 as well, and I did not have a problem with Common Core, and I was very lucky because all my boys went through abacus. And abacus is common core because you understand the reason why. So here's what we're doing is we're understanding why are we focusing on the add-in. When we focus on the add-in, we know what to do with the number. So here I'm going to add 7. I add 7. I want to add the 1. Now what we're doing is we're understanding how to move the bead. We're only going to move this one bead. Why? Why? This is so easy. It's easy for now, but we're laying the groundwork. We're laying a foundation. When you understand that there's a foundation, we're just going to lay it down. Now you notice when I add, I go up to the horizontal bar. When I subtract, I go away from the horizontal bar. So when I add, it goes to the horizontal bar. When I subtract, it goes away from the horizontal bar. When we talk about it, right, and I want to go away, so I'm going to do a -6. I'm going to take it away like this. When I add 6, I'm going to bring it together. So that's what we're doing here is every section of what we do is we focus on the actual number itself. Because we focus on the number itself, we know what we're going to do. This will help lay down the groundwork for the future numbers when we talked about it. So here's my 5. I'm going to add the 5. When I have the 3, I'm going to add 3. 1, 2, 3. I'm going to do 3 like this. I'm not going to do 1, 2, 3. We don't need to do that, right? We're big people. We can just move the three pieces like that. So so now our final answer is 8. Again, what we're going to do is we're going to continue on it, and we do every number just to see what it looks like. And I think maybe that's the other reason why mainstream school is a little bit difficult, because there's no structure and there's no framework of understanding. They talk about the doubles, but what is the doubles? 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5. Those are all doubles. But if you really think about it, understanding what the number itself, what you're doing to the number, it's about the journey, right? It's not about the destination. It's all about how do you get there. Like, we all want to be happy, but everybody's way of getting there is going to be different. So I'm not understanding what's the point of doing memorizing doubles, because every double is different. Every number is different. But as I go through the whole abacus, you will see that if you try to add a 4, there's three specific scenarios to add a 4, and I will show you. So the first thing we're going to do is the first scenario is this one. The first scenario is I'm going to add 4. Do I have enough? We're going to be like Bob the Builder. Yes, we have enough. I'm going to add the 4. So if I have 5 and I want to add the 4, is there enough? Yes, there is. I'm going to add a 4. Okay, so what's the next scenario? The next scenario is when I add 4, I want to add another 4. I don't have any more beads to add the 4. This is the second scenario. The second scenario of adding the 4. What are we trying to do? Well, in school, we're doing this great thing of teaching the kids how to make a 5. Great. But what are we going to do with it? There's nothing to do with making a 5. This is it. That's all they're teaching the kids how to do. Learn how to make a 5 and you'll be great. Okay, I know how to make a 5. Now what am I going to do? Well, in abacus world, we actually take it one step further. What does that mean? What? We're going to level it up. So when we level it up, the question is what? The question is not going to be 4 plus 4, memorize 4 plus 4 is equal to 8. No, what we're going to do is we're going to understand how to use this formula. This number sentence is what we're going to understand. When the queen of having, Mr. Queen, I was going to do a whole MAGA, make abacus great again. But I don't know if anybody would appreciate that. Make abacus great again. Okay. Whew. Oh, okay. So what we're gonna do is we're gonna do beginning parts of understanding how to do algebra. So now what we're doing is with abacus, we're going to introduce this thing called isolating a variable. Because we isolate the variable, why are we doing that? Because my question is 4 plus 4. I have a 4 and I want to add another 4, but I don't have any more beats to add the 4. What am I going to do? I can utilize this 5. I have no more freeloading 5s. No freeloading numbers. No freeloading. There's no freeloading here. You gotta work. You're here. You're gonna work. So I'm gonna do 4 is equal to 5. When I 5, right? This is not equal. They need to be equal. So now I have it go 4 is equal to 5 plus the 1. 5 minus the 1. Because I have this, now I have directions how to use the abacus. I actually have directions. What does that mean? I just need to add the 5. If I add the 5, now what do I do? There's too much. I need to remove the 1. So my final answer is 8. So what did I just do? Welcome, Jose. I love math so much. Yes. I love abacus, high school math. So what we're doing is we're substituting this information, this formula as a four. We can do it again to show you how versatile four is. But wait, there's more. So what we're going to do is we're going to do three. When we do three, and I want to add the four, there's not enough beats to add the four. What happens? Same thing. I don't need to memorize what four minus doubles minus one. I don't need to memorize that. Why? Because doubles doubles. It's whatever. So what we're going to do is we're going to understand four. We want to add the four. To add the four, what do? We plus the five and we take away the one. So my final answer is seven. What did I just do? I didn't take any concept and smash it all in. If you think about it, doubles is what? Plus two, three plus three, four plus four. Those are doubles. I gotta go. Hey, Mr. Clean, 100 pass next time. Next day, yeah. If I see you, like, bye, Mr. Clean. It was good to see you. Ah, it was good to see you. Okay, so why am I talking about doubles? I'm talking about doubles because if you really think about it, we again don't look at the add-ins. We look at the result. Don't think about the result. Think about the add-in. Why? Because now what we're doing is we're understanding when I add the four, do I have enough? No, I don't have enough. Oh, that's one stage. If I don't have enough, what do? I can plus the five minus the one. When I plus the five minus the one, my final answer is seven. Does that make sense? No? No? Cat? Did that work? Welcome to the real world. I don't know that word. Oh yeah, that's it. I hope you guys heard that. Welcome to the real world because abacus makes math very easy and simple to understand. So what we're doing is we're learning how to add. We're learning how to add with the swanky welcome, right? Somebody has taken the red pill. So what we're going to do is we're going to find out how to utilize again, right? You can do it another time. We could do it with this one. When we add the two, it's interesting to know that when there's a constraint, we can figure out how to make it work, right? If I give you a blank piece of paper like this, then it'll be like I can do whatever. So instead of adding you're substituting 5 into minus 1. Yes. So I add the 5 just as you said, Kit, and then I take away the one. Yeah, you're welcome. I'm using too much brain power trying to learn. Can't believe you're back on it such an early time. Welcome back. Welcome back. I really enjoy our lives. You know what? I want to say thank you guys for coming onto my lives. I really do appreciate it because when I'm looking at my comments and my comments and my posts, some of it's a little discouraging. But having you guys really refreshes my energy and I do appreciate it. So, Kit, did that make sense? What I just did? So instead of adding four, not yes. So instead of adding four, because we don't have any more beats to add the four, we can substitute it. We can substitute 5 minus 1. So that's why we do that. Yeah, you're the math teacher I needed in school. Oh, I don't know. I don't know. I appreciate that though. I do. I do appreciate it. But that's one of the things is like understanding why are we doing it? That's the one big question we should always ask. Why do we need to do it? What is the point? The point is if I don't have enough beads, what do I do? Right? So the question is here, right? This is an easy one. This is the same thing. So we have one. We have one and we want to add the 5. Well, adding the 4 is what? Plus the 5 minus the 1. Oh, that didn't work. We have 1. Is there enough beads to add the 1? No. 1, 2, 3. I only have 3 beads. But then if I know, I can do this. So then what does this do? This actually provides critical thinking. What we're doing is we're laying the groundwork to do critical thinking. Because when we're in school, we're just said, okay, 2 plus 4 is 6. Like we know this because we've memorized it. But now you know it because we've moved the beads, and it's not a childish thing. I don't know why they think it's childish to play with toys all the time. I think showing what we have makes it a lot easier. So that is scenario number two. Scenario number one is I have a five, I'm going to add a four. Is there enough? Yes. The Roman numerals. Yes, exactly. Roman numerals is very, very similar. So we do four, which is one minus five. Yes. I want an abacus and it looks fun, so fun. Oh yeah, I do. I do sell it on my abacus, on my TikTok shop, in my abacus shop, in my TikTok shop. You're right. You know what? You're absolutely right. That's a very good observation. Thank you, Kit. Yeah, that's a good one. I will have to add that to my notes because it's hard to relate everything that I've seen, right? So that was the other thing. Somebody said, well, the top bead can be the tally marks when we do one, two, three, four, five. Yes, that's very true. The top bead is that, but you cannot break the tally marks. Why did you start in the third column? Yes, thank you, Red Dragon. Yes, you're absolutely right. When I do this, I have a dot indicator. This is my label. My label is my ones. So when I look, this is my ones, tens, hundred thousands, 10,000s. And then between the ones and the tenths is my decimal. And then these two is my decimal places. So my tenths and the hundreds. If I chose this one as my Pokemon, as my, I'm sorry, as my indicator, I will move everything over and then everything shifts. So this will be my ones, my tenths, tens, and then here will be my tenths, hundreds, thousands. That's a very good question. Thank you, Red Dragon. Does that make sense? I hope that made sense. So, yeah, I was trying to. Yeah, let me know if you have any more questions. So we did the first scenario. If I have the five, I want to add the four. Can I add four? Is there enough beats to add four? Yes, there is. So what happens? I'm going to be like Bob the Builder. I said, yes, we do it. Yes, we can. So I'm going to add four. Okay, so the next scenario is when I have three on my abacus. I have three on my abacus. I want to add the four. Can we do it? No, no, we can't. Well, yes, we kind of can. What we're going to have to do is so what are we going to do here? We're going to modify. We're going to do 4 is equal to 5. When we do 4 is equal to 5, that's not the same. That's not the same. We got to make it the same. We got to do it like this. So what does that mean? We do 3 and then plus the 4. Plus the 4 is plus the 5, right? Yura? Thank you. I did that last night. I was trying to be like a little bit more catchy. So we have 5 and then minus the 1. So our final answer is 7. Ah, but you're not funny is back. I think I'm hilarious. So hopefully the sound is not too loud because I know that you do the clapping and stuff. It's like it blows out my ears, and I might just lower it down a little bit. So let me. Yeah, my sound effect's only at 20%. Hopefully you guys can hear that. Okay, so that's what we did is we modified. What we did is we isolated the variable. When we isolated the variable, we want to do is we want to subtract the ones on both sides, and we made this. So that's a scenario number two. After scenario number two, thank you, Smoothie Pappy. After scenario number two, what happens? We have eight. Not eight. We have seven. We have eight. We have seven. We have seven. Right? It's a seven. Five, six, seven. We know how to do seven. I want to add four. But notice I don't want to add four. I'm learning today. Thank you. Yeah, you're welcome. I'm happy to share my knowledge. Thank you for the rose. Thank you for the rose. Oh, what are we doing? Plus the four. Can't plus the four. What do you mean? Yes, we can. We just learned how to plus the four. Yes, yes. Plus the four is what? Plus the five minus the one. Plus the five minus the one. So if I want to add the four, I want to plus the five minus the one. Okay. I want to plus the five. Oh, yeah, I can't plus the five. I'm already using it. So what's the next scenario? The next final scenario under the like a little can the thought behind the thought behind five, six, seven, I got lost. Oh, Enric? Oh, five. So we do one, two, three, four. After four, because it's touching the horizontal bar, this is four. And then this is five. This will always be five no matter what. This will be always be five. So when we count, we go back. We go one, but we add the five, now we have six. We have two, we add the five, now we have seven because it's five, six, seven. Five plus two is seven. When we have three, one, two, three, we add the five, now we have eight. 5, 6, 7, 8. 5 plus 3 is 8. Then we have 4. We know what 4 looks like. 1, 2, 3, 4. We add the 5. Now we have 9. 5, 6, 7, 8, 9. Together we have 5 and 4 is equal to 9. Yeah? No, thank you for the question. Okay, so I'm going to continue on with what the next thing is. What we're learning is how to make a 10. We know how to make a 10. We're being taught this in school. Every time I hear it all the time. Make it 10, make it 10, make it 10. But this is as far as it goes. What are we going to do? Well, let's make a 10. We're going to add a 4, right? We're adding a 4. This is the next scenario. The next scenario is how to add a 4. How do you add a 4? We know how to add a 4. We add a 4 is plus 4 is equal to, I'm sorry, 4 plus 6 is equal to 10. We know how to do this. And then what's going to happen? We have to, so what we're going to do is we're going to modify. We're going to isolate this variable. When we isolate this variable, right, what we're going to do is we're going to do 4 is equal to 10, right? No, that's not right. Why? Because this is not equal. We need to balance it out. We need to minus the 6. So my question was 7, and I want to do plus 4. Plus the 4 means modification. Yeah, right? So what we're going to do is we're going to add the 10, 0, 1. We're going to add 1 here. 0, 1, 10. That's how we do 10, right? 0, 1. That's 10. And then it says to take away the 6. So now we're going to take away the 6. So my final answer is 11. So we just did is we blew through how to make a 5, how to make a 10. And that's it. That's it. That is everything about adding and subtracting, other than me ranting about the school system. So, yeah. Anybody have any questions? Whew. Corgi, my Corgi, what? Thinks I'm cool. So we want to do another one? We could do another one. We did 4, we could do 8. We could do 8. So we have 8. When we have 8, it's the same thing. I was with you, then you lost me. Oh, can I do the floating pointing thing? Oh, yes. Hold on just a minute, Swanky. So I just joined and I'm so lost. So there's my little floaty pointy thingy. Is that what you're talking about? We have our ones, our tens, our hundreds, our thousands, our 10,000s. When we look, this is our decimal. It is because it's on the tens place. Yes, because it's on the tens place. When we look at oh, that's not it. When we look, it is telling you what to do. It's telling you that this, how do we make a 10? So we have 9, and 10 is 1 and a 0. This is how 10 looks like. When we look, this is what 1, this is 10, right? 1, 0, and 1. That's what this is. We're going to add a 10, 0, and 1. When we have 7 and we want to add the 4, we want to do 0, 0, and 1. So we want to do 1, and then here it says take away 6. So all we got to do is take away the 6. Okay, interesting. Didn't know you were limited to whole numbers and integers. Yes, we are limited to whole numbers, integers, and decimals. Thank you for explaining. Yeah, because of the place value. Exactly. And people ask me about, can I do calculus on it? I was like, no, unless you can figure out how to do calculus with whole numbers and integers. And we don't do negatives either, because how do you get a negative of a, yeah, I don't know how you do integers. How we can do negative if we have something on the abacus, but if you have 0, how do you take something away from, how do you take a physical object 0 away, negative away from a physical object? I don't know, right? Because it's not, what is it? It's not water. We don't go underwater. What it is, it's a physical item. I've been out of school for 10 years now. I've been out of school for a lot longer. But I'm actually back in school because my kids are in school. Have you done a race with a slide rule? I have not. I don't know anybody who knows how to use a slide rule. But but you know what? There is a video race about this woman doing calculations in her head, and Bill Gates is on a calculator. I've seen that, and she kills it every time. I seen a race of a boy who does the 100 add-ins, right? 100 lines of adds, like I think they're 4 digits or something, and he was able to do 100 of them in 31 seconds or less or something. It was crazy, and he beat the world record. Oh, my dad was in college. They did slide rule races. You know what? There is abacus races. Just so you know, there is abacus competitions, and it's international. It's pretty big. There's a whole federation of abacus. Um, Enrique, I got lost because the second beads. Why not just the tens place beads? So when we're adding a 10, it's like carrying, right? It's like borrowing and carrying. You know how in school, they teach you how to borrow or they carry, right? It was what? I don't know. When um 8 plus 5, right? And you figure this out and you have to carry the 1. That carry the 1 is adding a 10. Does that make sense? So in abacus world, we carry the 10. Girl, goodbye. I'm sorry. Followed the live. Oh, that's the username. Oh, okay. Sorry. I had he had one of the first calculators was physical plugged into the wall for a power. Yeah. My dad was in a room that was one giant computer. It was a whole room. So if we did this, right, we can do it on the abacus. We do 18. We do 18 on the abacus, right? Now, what we're going to do is we're going to add the 5. When we add the 5, what are we going to do? We're going to add the 5. We know how to add the 5 on the abacus. I need to move this. Where's my, okay, remember how to add a 5? We can add the 5. To add the 5 is what? Plus the 5 is equal to plus the 10 minus the 5. We can do that. So what can we do? It's the same thing. We have 18. I want to add the 10. I'm going to add the 10. I'm going to minus the 5, and I take away the 5. So my final answer is 13. No, 23. 23. Yeah, but 11 wouldn't, what? Yeah, but that would make 11. Wouldn't that look like 10 too? No, no, no. Because there's only two ways. Because we don't make pairs of 11, if that makes sense. We don't say, what's the pair of 11? We always say, what's the pair of 10? So you could talk about it, right? You could say pairs of 12, pairs of 13. But the thing is, yeah, this is a decimal. We're talking about decimals. We're talking about 10, a base 10. And when we talk about base 10, we want to do multiples of 10. This is not a base 16 or a hexadecimal or what have you, if that makes sense. So you can have, and I think that's the difference between abacus world and mainstream, is because they put everything under the sun, whereas in abacus world there's a specific framework. So when you look, we only do adding the 10 and adding the 5. When you have this solid and concrete, you will be able to add anything. But I know in mainstream math, they're like, okay, well, let's learn how to make a 12. And they'll be like, I don't know, 7 plus 5 is equal to 12. And I'm like, well, why? Why? On the abacus, we can easily show you what 7 and 5. So I have 7 here, and I add the 5. I'm adding this 5. This 5 is a fundamental pillar. That is plus the 5 is equal to plus the 10 minus the 1. So we're going to plus the 10 minus the 5. I'm sorry, I said that wrong. But so let's say 11. Let's take that, right? Enrique, we take 11. Okay, so let's do 11. I'm sorry. Give me a question that would make 11. I'm not sure how to. I'm not sure in my head how that would work. So if we have this, right? We have 11. So if we did 8 plus 11, if we did that, it would still be, hey, hey, hearts, welcome back. If I want to add 11, it would just be 1 and 1. No, see, that's different, right? If we do 6 plus 5, okay, these are two different things. Why is it two different things? The first thing we're going to do is we need to understand how to add a 5. We know how to do that. Is this the same as this? No, they're different. Why are they different? Why? Why are they different? I will show you. I will show you. So what we're going to do is we're going to plus the 5. We know how to plus the 5. Plus the 5 is equal to plus the 10 minus the 5. Okay, we know this already. We know this already. So we have the 6 and we add the 5 plus, and then that's it, right? We got 11. We got 11. We got 11. We not, right? Now this is different. Again, it all talks about this here. It is all about the add-in. When we do the add-in, right, we have 5. Now we want to add the 6. To add the 6 is what? We know this concept. Plus the 6 is plus 6 is equal to plus the 10 minus the 4. I'm going to plus the 10. But notice I cannot minus the 4. This is now what we call a two-step equation. This two-step equation, how do we take away the 4? We know how to add the 5. If we know how to add, we will know how to subtract. So when we subtract, it's minus the 4 is equal to minus the 5 plus the 1. So we minus the 5 plus the 1. My final answer is 11. I don't know if that made sense. But those are the concepts. Once we understand these two formulas, you will know how to do everything in adding and subtracting. Did that make sense? You lost me at the 5. Okay, so let's go back. Let's go back because Mad Max, you're a magician, or I was just blown away. Yeah. Okay. I'm talking too fast. Let's go back. Let's go back. Let's go back. Here. We know this, right? We know how to do this. Is that okay? Let me know if you guys remember if this is okay. You know what? I have steps in my head, but when people ask me questions, I start jumping. So, okay. Does that make sense? Do we know this? Do we understand this? Let me know in the chat. 4 to say yes, I understand. Put a 4 if you understand. Put a 4 in the chat if you understand what I'm trying to say. Put a 4. Okay, good. Okay, good. So I'm going to go away from here. So then what's the next one? Okay, the next one is when we have the 4, we can also subtract the 4. We're going to subtract the 4. So that was probably the one thing that I missed. So what's going to happen is when I want to take away the 4, why do we want to take away the 4? Well, the question is I want to 8, right, minus 4. Well, when we do 8 minus 4, there's not enough beats to take away the 4. I have 8. When I have 8, 5, 6, 7, 8. When I have 8, I want to take away the 4. I can't take away the 4 because there's not enough beats. 1, 2, 3. Minus the 4 is equal to minus the 5. But again, this is not balanced. So we need to plus the 1. So this is directions now. We're now looking at directions. We take away the 5 and we add the 1. So my final answer is 4. Does that make sense? So when you look, you will see that there is a number pattern. I have 8 or I have 4. Oh, sorry, that's not work. So I have 8. If I have 4 and I want to add another 4, notice the number pattern. It's 1 beat on top and 1 beat on the bottom. When I do it the other way, when I minus the 4, it's minus the 5 plus the 1. So what we're doing is we're seeing this number pattern, right? It is not about muscle memory for right now. Right now, it's to see the number pattern. Yeah, and now, you know what? I'm sorry, Kat, for making you confused because we blew away. And I need to go through and say how to add and how to subtract. When you understand how to add, subtract, then we go to the bigger numbers, adding and subtracting. So does that make sense? So what we are doing is because we know how to add, we will know how to subtract. It is just the opposites, which is the great thing. Whereas in mainstream math, you learn one way to subtract and you learn a different way to add. But now we're talking. But now, see, the thing is I have this concept. You've seen this before. We've done it before, and then we changed it. Okay, so we're good there. Okay, good. So let's do the next one. Let's say we do the next one. The next one is how to make a 10. And I know I blew that one through too. So what we're going to do is we're going to make a 10. We know how to add 5, right? We know how to make a 5. Now what we're going to do is we're going to make a 10. Okay, wait. Before we do that, we can actually do it again for the 3, right? We could do it for the 3. Oh, hey, Kyler, can you make a live about how to read an abacus? You know, I made a post about how to move the beads on the abacus, and I got a little bit of hate. They're like, "Why are we learning how to move? Why is this a tutorial?" Okay, wait. So before we go forward, I forgot. This is one of the things you will notice that the beads have a ridge. There's an edge. This edge helps you move the beads. Okay? So you don't need to stick your whole finger in there and move the beads. What you do is you just gently brush the brush the edge just like that. That's all we're doing when we move the beads, right? So when I count, we want to be able to count that goes to the horizontal bar. This is the horizontal bar. Notice I have my left hand. I have my left hand and I hold it. It's like paint. Yes, yes. So what I'm doing is I'm holding it. I gotta hold it. I gotta stabilize it. Why? Because if the abacus moves very easy, right? And so you want to be able to make sure that you stabilize the abacus and we move it. And we're gonna count. When we count 1, 2, 3, 4, all the beads that are touching this horizontal bar is now being counted. Kyler, so this is 4. When we do 4, now we have 5. The top bead will always be 5. So we have 5, 6, 7, 8, 9. After 9, we have 10. How do I know? Because I have my place values. I have my ones, my tens, my hundreds, my thousands, my 10,000. So when I look, my decimal sits between the ones and the tenths. So when we have it, this is my decimal, then these two are my decimals, my tenths and my hundredths. So now we have 10. This is understanding. This is 10. So we have 10 and we can count by tens now. 10, 20, 30, 40, 50. The top bead will always be 5 no matter what. Now, however, be careful. Don't don't flick too hard. Like Thor when Zeus flicked too hard. Don't flick too hard because what I just did is I just messed up my whole answer. Yeah, it is a calculator, but it's more like it tracks your numbers, really. It just really tracks your numbers. Your brain is the calculator. What your brain is going to do is the calculation. Yeah, does that make sense? Okay, so, okay, yeah. Don't flick too hard. I got to do that. You flicked too hard. All right, I gotta get a sound clip on that one. Don't flick too hard. So here we're back to here. Now, what we're gonna do. So what's gonna happen here? We're doing this. Let's do 3. Now, if you notice, I'm gonna do 4. I'm gonna do 4 plus 3. Notice when I do 4, I want to add the 3. I cannot add the 3. What do? I know this concept. I know 3 is equal to 5. That's too much. So I need to minus the 2. Minus the 2, then we can balance it out. So when we minus the 2, I want to plus the 5 and I want to take away the 2. So my final answer is 7. Does that make sense? So what we're doing is we're utilizing this concept of how to make a 5. Oh, that's not it. Because we know how to make a 5, right? We're leveling up our concept. We're leveling up our information. We're leveling up the concept of how to make a 5. So we did how to make a 4. I'm not sorry. We figured out how to add a 4. Now we can do a 5, right? Okay. See you later, Kyla. So again, right? We can do it for all of these. These are all the pairs. These are the pairs that you need to understand. Okay. So let's take the next step. So now we know how to subtract. Now we know how to add. We're done with the 5s. Now the next thing we're going to do is the 10s. We did a little bit about the 10s, but let's go back and let's go review a little bit. So we're going to make a 10. When we make a 10, let's do 9 because 9 has the most numbers. 9 has the most questions that we can utilize. So we have 4. We have 4. I want to add 9. I want to add 9. I can't add the 9. This is very familiar. Doesn't this make sense? This is very familiar. So I give you the concept of 9 plus 1 is equal to 10. What? So then what do? We want to add the 9. We want to add the 9. So 9 is equal to plus the 10 minus the 1. Okay, when we look, we want to plus the 10. 0, 1. 0, 1. We want to add the 1 here. So we add the 1, and then that's done with that, right? And then we want to minus the 1, and we take away the 1. My final answer is 13. Oh, maybe I should do the other one. So does that make sense? What we just did is we just making a 10. We're making a 10. Maybe we do this one better. Maybe we do 8 instead. Oh, I see. So we did, what did we do? We did 8. Let's do 8. So we have 3. We have 3. I want to add the 8. Notice to add the 8, I can't do it. So what do? I have to plus the 8 plus 2 is equal to 10. It's clicking. Yeah, right? I'm telling you. So here we're going to add the 8. To add the 8, we know this. 8 is equal to 10 minus 2. So what's going to happen? I go 8 is equal to 0, 1, 10. That's what we do. 10, 0, 1, 10. So I add the 1 here, and I'm going to plus the 2. I'm sorry, minus the 2. So I take away the 2. So my final answer is 11. What did I just do? I just did 3 plus 8. And then if you notice, I only focus on the add-in. My add-in is 8. Okay, so does that make sense? So now, look, minus 2. Well, if we saw it before, minus 2, let's see. If we can't minus the 2. Okay, so that was where we were at. So now we know how to add a 10. We know how to add a 5. Now what are we going to do? We can start going into let's do a little more. Let's do a little more adding the tens. Hello, Homelander. Welcome. Let me know if you have any questions, and please don't spam the chat because I can see you. I can see you, Homelander. All right. So what are we going to do? Oh yeah, we're going to continue more. We're going to continue more. We're going to do 4. We do 4. We do 4 plus 8. Now what we're doing is we're just solidifying our concept, right? We're just solidifying our what we're trying to do. So I want to do 4. If you notice, when I have the 4, I don't have any more beats to add the 8. When I add the 8, right? I don't have any more beats. Can we do it? Well, we'll have to modify it. Modify. What we're going to do is we're going to plus the 10. We have this concept. We know this rule, this formula. We know this equation. It's plus the 10, take away the 2. Modification. I don't know if I want to. Yeah, I think I'm going to have to use that. So then my final answer is 12. My final answer is 12. Does that make sense? Crack in the sidewalk 44. Yeah. Swanky. Does that make sense? There's only 3 people in the chat. Kyler already left. And I don't even know if Enrique's still awake. So, how are we doing? The only thing I figured out my head long before we played with the button. That makes so much sense. Oh, good, Victoria. Good. Okay. So we're going to continue on with adding. When we add the 9, right? Okay, good. So when we add, we have a whole slew of questions. So if you look, we have 7. We can do the same thing with the 7. Oh, that's not right. 7. There we go. 7. So 7, 7, and then 4. Let's do 7 and 4. So we do 7, and we want to add the 4. If I have 7, 7, and I want to add the 4. Can I add the 4? No, I want to do 4. There we go. Sorry, wrong way. I have 4, and I want to add the 7. I cannot add the 7. Earliest calculators. Yeah, are yes. So, thank you. Crack in the sidewalk 44. That's a funny question. Okay, so 7. 7 is equal to plus the 10 minus the 3. So we're going to plus the 10, and we're going to take away the 3. So my final answer is 11. Kim, Oh, okay, Kim. So what did we just do? We understood that we have this concept 7 plus 3 is equal to 10. And then what do? We substituted, we modified it, we isolated the variable, we isolated the 7 variable, and then we're substituting this information into the 7. So then when we look, we can actually utilize it and move our abacus. When we have 4, let's go back to 4. When we have the 4, I want to add 7. All I got to do is plus the 10 and then take away the 3. So my final answer is 11. What's next? We can do more. We can do more. Okay, but I think we're ready to understand what I did before, the little magic trick that I said. Abracadabra abacus. That's it. Abracadabra abacus. So what does that mean? Well, now we understand how to make a 4, how to make a 5, how to make a 10, right? The question is what? Well, one question is we have this thing, we have these things. Actually, I just go back to this one. Abracadabra abacus. Oh, I should add that. I'm going to add that in. Abracadabra abacus. Okay. We were talking about 11. This looks very similar, but they're not. Why? Because the add-ins are different. Because the add-ins are different, that's what makes the math problem, the math question different. Right? It's all about our experiences. So here is 6. I'm going to add the 6. When we add the 5, we know we're going to plus the 5 minus the 5. Right? When we add the 5, there's not enough. There's not enough to add the 5. What do? We plus the 10 and minus the 5. So my final answer is 11. We've done that. Okay, fine. But now what's going to happen is it's going to take it one step further. Why? 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 Well, you're going to see when we do this, we have 5. And then we have 6. We want to add the 6. To add the 6, this is what we call a two-step equation. You know how to do it. We talked about how to make a 5 and how to make a 10. You know how to do it. How do we do it? Well, we know we start with plus the 10 minus the 4, right? We're going to plus the 10 and then minus the 4. So I'm going to add the 10, right? 1 and a 0. And then I'm going to minus the 4. Wait a minute. I can't minus the 4. Thank you so much for the rose, Kim. How do I minus the 4? Minus the 4 is what? It's one of our pillars. Minus the 4 is minus the 5 plus the 1. What? Yeah. So all I have to do is minus the 5 plus the 1. This is why we call it a two-step equation, because this 4 is not Bob the Builder anymore. This 4 needs to get modified. This 4 needs to have a substitution, and this is what we substituted. Did that make sense, Enrique? Yura, I don't know if you're still here. Kat, does that make sense? Swanky. I don't know if Swanky's here either. There's 30, there's 31, but Kim's the only one that's mentioning. Yeah. Yes, that helps. Right. That's what I'm saying. Because we jumped a lot, and so I apologize for jumping too quickly. I get excited to explain like everything about abacus. Yeah. So that's what the difference is. We can do another two-step. This is what we call a two-step equation. Why? Because we have to actually bring one into the other. But that's what I'm saying. You have to Tetris your way through. And it's a different way of thinking. It's a different way of thinking because in school we were never taught to Tetris our fundamentals. These are like building blocks of Lego. You get a square and you figure out what you're going to do with it. That's the interesting thing about this. Like it really mimics what we're trying to do with everything else. Like we have our elements, we have our ingredients. Can you multiply on the abacus? Yes, Larry. Yes, we can multiply on the abacus. So what we're doing is we are understanding though how to add and subtract. What these are the building blocks like Legos, like pieces of Lego. Every Lego piece is very different. How do you use the abacus? Golden horn. what we're doing is to learn how to read the abacus. The first thing you need to do is understand that this is one. So after one, this is two, three, four. Anytime this is touching the horizontal bar, this is counted. So we have four beads counted, and then we have five. Because we have five, this is being counted. We have six, seven, eight, nine. After nine, we have 10. 10, how do I know? Well, when we look, we have our place values. We have our ones, our tens, our hundreds, our thousands, and our 10,000. And if you're looking for books, I'm having this books available in my TikTok shop. Or and then I also sell the abacus too. If it's just for you, I would recommend the 13 column abacus. If it's for your child, I would probably recommend the 7, and then you can graduate them to the 13 column one. That's what I would probably do. So, okay. Um, they work exactly the same, just one has color and one doesn't have color. And in this one, because it's 13 columns, size matters. So, golden horn, did that make sense how to read the abacus? So when we read one, two, and then we can count by tens, we can count by tens. 1, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Size matters. Yeah. I like that. I like my jokes. I have my jokes. Yeah, not a problem. Like, thank you. So we can do another two-step equation. There's a lot more two-step equations, but that really solidifies. And then we start talking about critical thinking. So here's another one. We could do 7 plus 7. 7 plus 7. Again, we're not memorizing our doubles. What we're doing is we're utilizing our formulas. So we have 7 on the abacus. Knowledge and the jokes. What a combination. Yeah. Yeah, thank you. I appreciate that. So we have 7 plus 7. We don't have another 7 because this is only 2. So what are we going to do? What are we going to do? We know that 7 and 3 are a pair. Because 7 and 3 are a pair, 7 is equal to plus the 10 minus the 3. So what are we going to do? Plus the 10, 0, 1. Plus the 10, 0, 1. I'm going to add the 10. I'm going to take away the 3. Ruh-oh! Ruh-roh! Ruh-roh! I don't know if you guys know Scooby-Doo anymore. I don't know if that's like an old thing. That's an old person thing. Ruh-roh! Oh my god, Shaggy! So minus the 3. Notice I cannot minus the 3. I don't have any more beads to minus the 3. What do? I know that I can use the 5. To minus the 3 is what? Minus the 3. I know we can minus 3 is equal to Scooby-Doo. Yeah, okay, good. Minus the 5 plus the 2. So if you look, I can minus the 5 and I plus the 2. So my final answer is 14. So this one is also a two-step equation because what we did is we minus the 3 is equal to minus the 5 plus the 2. That's what we did. And so what we're doing is we're just following directions. Everybody says follow the directions. And so we were do what when we talk about this formula, we just follow the directions. And I think that's what makes it easy. It's easier because we are given directions on how to add. We're not thinking of many ways of doing it, right? We don't need to expend extra brain power if we already have the fundamentals. So that's one of the fundamentals. How are we doing? Do we do some more two-step equations? Yeah. Thank you guys so much for the likes. Okay. What are we doing? We're going to do some more two-step? We can do some more two-step. It gets more complicated. But see, the thing is now we're talking about critical thinking. We're doing, we were doing good learning so much. Yeah. Yes, I'm still fuzzy on it. Yeah, not a problem. We'll keep going. You know why? Because don't forget, you just learned. It takes a few hours to go through this. It takes a few hours to go through this, and then it takes a few more hours to combine the two. So don't. I mean, we can keep going. That's not a problem. I just want to make sure that we're at at a better pace, because sometimes the class goes really fast. Sometimes the class goes not so fast. But it's fine because we need to understand. But before you go into other things, right? Because we are going to other things, we need to understand how to do the basics. So we can do another two-step equation. Here's another two-step. Let's do 49 plus uh um 5, right? We know how to add the 5. Not a problem. When we look, we have 49, 40, and then 9. We want to add the 5. How do we? Okay, let's see if you guys remember. How do we add the 5? Do you remember how to add the 5? How do we add the 5? How do we add the 5? Do you remember? All I understand is counting and not using it for, but not using it for adding and subtracting. We're doing it right now. We're adding right now. How do you make a 5? If I have not enough beads to add the 5, what is the formula? Do you remember the formula how to make a 5? So here is a hint. There's my hint. How do you make a 5 out of that? Right? We know how to make a 10. All we got to do is modify and figure out how to make it into a 5. So what we're doing is we're moving some stuff around. Does that make sense? I wasn't ready for a quiz. I'm not here just to talk. I'm here to be interactive. Take away 10. Almost. Almost. We're going back to here. We're going to make a 5. To make the 5, what are we going to do? We're going to isolate the variable and we're going to add the 10, right? Because that's what this is. Plus the 5 is equal to plus the 10. Surprise quiz. I know. I'm making sure you guys are not sleeping. So this is too much. What do I do to balance this out? What do I do to balance this out? How about that? What do I do to balance that out? Minus the 5. Thank you, Z. Yes. Thank you, Damien. Yes. No, you guys are absolutely right. We're going to but we learn, yes, we're taking it slow. We're going to minus the 5. So does this make sense? What we just did is we took this concept and we're isolating this variable. We're going to isolate this variable. When we isolate the variable, we want to subtract 5 from every side. So when we look, we're back to here, right? I want to add the 5. When we add the 5, there's not enough. So I need to go to my formula and figure out how to add a 5. So I'm going to add a 5. I'm going to plus the 10 minus the 5. I'm going to plus the 10. Remember, when I plus the 10, I'm going to take away the 5, plus the 10. So let me rewrite it. I'm sorry. Let me rewrite it. Minus the 5 plus the 10. This is the same. These two are the same. It's just different. It's just a different order. Does that make sense? So what I'm going to do is I'm going to take away the 5 first, and then I'm going to plus the 10. Well, I can't plus the 10. If you notice, 1 and 0. 1 and 0 plus the 1. I cannot add the 1. Do you remember how to add the 1? We remember how to add the 1. How do you add the 1? To add the 1 is 1 plus 4 is equal to 5. Remember, 1 plus 4 is equal to 5. If I want to isolate this 1, because that's what I want to do, I want to add the 1 here. I need to 1 is equal to plus the 5 minus the 4. So I'm going to plus the 5. I'm going to take away the 4. So my final answer is 54. Does that make sense? So what we just did is we added, I'm so tired, I'm sleeping class. right? So what did we just do? We did a two-step equation. How is it a two-step? Because we had to modify, oh, I didn't write it. Because we had to change this one up. That we had to change that one up. So that's the two-step equation. So, and it takes a little bit, right? It takes a little bit to understand, but those are the formulas we have, and we just have to figure out how to utilize them. All right. So for those people that just came in, let's do a review how to read the abacus. All the blue beads, I wasn't there for that. Oh, interesting. All the blue beads have a value of 5. So we have 1, 2, 3, 4. And then we have 5. This is the value of 5. We have 5 and then 6. Because this is 6, it's being counted on the horizontal bar. So when we came here, I'm sorry, this right here is the horizontal bar. This horizontal bar tracks our numbers. So this is 6. So if I did this, that's 6, 6, 6, 6. These are all 6. These are all 6. Now when I clear it, this is now 0. When we look, this is 7. How do I know that this is 7? This is 5, 6, 7. 5 plus 2 is 7. And then we have 3. 1, 2, 3. But then if I add the 5, because the 5, this top bead will always be 5, when we add the 5, now we have 8. When we have 4, 1, 2, 3, 4, I know what 4 looks like. This looks easy. But now the question is what happens when we add the 5? Adding the 5, right, is now 9. So 4, here's 4 plus 5 is equal to 9. Yes, thank you, Enrique. So when we look, this is 9. Now when we have 10, 10 is this. What? 10 looks very similar to 1, but just a different place value. 10, 1, 1, 10, 10, 1, 10, 1, 1, 10. So if I did this, these are all 1s. That's all 1. But when we look, this is 1, this is 10, this is 100, this is 1,000, this is 10,000. So what we're doing is we're learning how to read the abacus. When we read the abacus, then it's easy to understand when we don't have enough beads to add and subtract. So when we're looking at it, we have 9. This will always be 9. This is 9, that's 9. These are all 9s. When all the beads are together like that, these are all 9s. But then the thing is when you put it as a place value, every column, these are columns, has a place value. Every place value has a label. Thank you for the follow, Z. So when we look, we have our 1s, our 10s, our 100s, our 1000s, and our 10,000. And between the 1s and the tenths is our decimal. Our decimal does not sit on a specific place value. What it does, it sits between. So now we know we have decimals. So we have our tenths and our hundredths. Magic. Abracadabra abacus. I'm getting impressed each second. I'm going to claim that. Abracadabra abacus. Oh, I'm going to change it. I'm going to say it. Okay, yeah. Abracadabra abacus. So when we look at it, right, all of this touching the horizontal bar is now 5. When we write it, what does it look like? It looks like this. 5, 5, comma, 5, 5, 5, decimal 5, 5. Now look, if you notice, there's a thing right here, this dot, right? This is my indicator. Notice my indicators are every, what, grouping? Separate group? I don't know what you call it. Group separator. There's a group separator, right? That's what the comma's for. This is my thousands. This is my ones. This is my thousands. So when we look at it, if I had a bigger abacus, because size matters, this is my 13 column abacus. With my 13 column abacus, I have, again, my indicators. I have my ones, my thousands, my millions, my billions, my trillions. So when we look, hey, ghost ASMR. That would be the greatest. It's like a rattle. That's all it is. It's a rattle or it's a massager. Okay. Um, So again, you can choose any one of these to be your indicators. You can be any one of these as your what do you call it, as your ones indicator. You can choose this one like a Pokemon. You can choose this one or this one or this one. It all just depends on where you want to go, what you want to do, how big your number is. We're only talking about numbers, right? We're only talking about how big a number is. So we have our ones, our thousands, our millions, our billions, and our trillions. But if you wanted to track the national debt, you might need a larger abacus, which is 23 columns. 23 columns is the amount of digits that we have. So when we look, it's still the same concept. The concept is still exactly the same, just more numbers. So I'm going to start here because I have my ones indicator. My ones indicator is right here. I'm going to do 1, 2, 3, 4, and then 5. Because I have 5, I have 6, 7, 8, 9, and again 10. So it's all the same. It doesn't matter if you're here or if you're here. Even if you are colorblind, you don't need to know what you don't need to know what these colors are. What you need to do is understand how the beads look. This is made out of plastic and they work exactly the same. Now the reason why, be careful, they're very easy. Is that the national debt that you need a bigger abacus? Yes, exactly. So that's why I have the bigger abacus to track the national debt. But notice though, this is made out of bamboo and it's nice, but I've had this one for about 20 plus years. This is made out of plastic. It's exactly the same. Notice how easy the beads move. So that's why you have to hold the abacus, stabilize the abacus. You have to stabilize the abacus, and then you can do your calculations. Because if you don't, then your whole thing will move, and then your answers will get messed up. Then you added too many zeros, right? So it actually doesn't matter. The 24 ounce still looks brand new. It looks a little weathered. You can see it, but this is made out of bamboo. It sounds different, but they're all the same. And this is the size. This is a standard size. Just so you know, they're standard sizes. So even if you have big burly hands, the idea is to just move the edge of the bead. I don't remember if I talked to you about that. But yeah, it's always just the edge and it's being delicate, right? Always just move the edge of the bead. Just because you have big burly hands doesn't mean that you cannot use this. This is a standard size of an abacus. It's plastic. It's easy to move. Make sure, oh, that was the other thing. Make sure that you're on a leveled on a level table, because if you're on an angle like this, then your answers might get a little bit wonky. Because they move so easily. Because it moves so easily, you have to like have it on a flat surface. Um what else? What else? I think that's about it. I think that's about it on like how to move the abacus. But you have to make sure that's the big thing. Some of the complaints was like, it's so difficult. I'm like, it's about attention to detail, right? So when we look at it, we want to make sure we understand we have 5. This is 5. Sometimes when you read the abacus, people forget that this is 5. Sometimes they forget it's there. So the abacus has attention to detail and also the delicateness too. Because you don't want to just flick too hard. So you'll notice what I mean by flicking too hard. If you do this, notice that there's these beads that are no longer touching. I was wondering that if you were to making big abacus, would it be easier to move? You could make it bigger, but then you're going to be like doing this, right? So the movement is a lot tougher. You'll be using more wrist more. This one is a Chinese abacus and it's a lot bigger, but I don't know if they do Chinese abacus competitions, right? And the flick is harder. So this is also made out of bamboo, some sort of wood, and it takes a little bit, and I guess you would have to practice your strengths in your fingers, to do it. And it works exactly the same, similar. It works very similar. So I have 1, 2, 3, 4, 5, and then that's 5. So 1, 2, 3, 4, and then 5. We have 5 here. We can trade it in for this. This is the top bead. This top bead can be traded in. So we're going to trade this in. So this is now 5. We have 5, 6, 7, 8, 9, 10. Because this is 10, we could trade in to the top bead, right? If this is 10, we could trade it in for this. So now this is 10. You could make a bigger one, but is there one? I don't know. I don't know if there's a bigger abacus soroban. I was wondering why there's 2 beads on the top. Yeah. So each bead on the top is always value of 5. This is a Chinese abacus. It's a 2 and a 5. Yeah. Yeah, yeah. It's all about the patterns, and that's the interesting part about it. It's all about the patterns. It's not about it's not about muscle movement. It's That's later on. It's to see the patterns, and it's also to understand how the numbers work. So that's the interesting thing about it, right? Like when you see this, this is just a bunch of abstract symbols. But when you start moving items like this, it makes a lot of sense. So how do you count on the average using how do you I'm sorry. So how do you count with the abacus using the two beads on top? Same way. So one, two, three, four, five, and then six, and then seven, eight, nine, 10, 10. So this is 10, and then we will trade it into this, and then we'll trade it into this. Um, you could do what? You could do multiplication. 5 times 5 times 5. Okay, wait, sorry. So 5 times 1, 5 times 2, and then because I have this, I'm going to trade it into this. So now I have 2, 5 times 2, and then I can do 5 times 5, so we have 15. But because we have this, I'm going to trade it in for that. So we have 5 times 15, and then we could do it again. 5 times, I don't know, 4 is 20. Because we have 20, we can trade this in to up here. So then we have to do this, and we can trade it into that. So there's a lot of tradings in the Chinese abacus. It's interesting. I mean, they were talking about, 6 times 1 is 6, and then 6 times 2 is 12, because this is 10, 11, 12. And then because we have this, we're going to trade it in for that. So then we could do 6 times 3, 6. So then we have 18. And then 6 times 4, do it again, right? We have 20, 24. We have to trade this in. So this would be 10. So we're at 24 top. At the first explain on top. Guess who's back? Hey, balls. Hey, Connor. Welcome back. So the abacus is wow. That abacus is more advanced. No, 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 no. This Chinese abacus is not advanced. It's just more redundant. There's a little bit more extra steps. That's all it is. The Japanese came around and they made it more efficient. That's all it is. That is all. Okay. So we're back to here, and then we're back to here. So does that make sense about how to do a two-step equation? Oh, wait. So we're here. We understand that. Okay. We understand how to do that. Now, why are we doing this? What we're trying to do is we're trying to understand how to move the beads. When we move the beads, we only want to move the one bead up and down. One, two, like are, he, live, everyone, she makes a lot of sense. Oh, hey. Oh, I like the line. I was like, I was trying to, the acronyms. It was the acronyms. So the two beads on the top equals to 10. Yes, you're absolutely right, Enrique. The two beads always have at the top is always going to be, yeah. So it's 5 plus 5. So this is 10. So if I did this, that's 20 because this is 10 and then this is 20. Yeah. And so we have 20. So it's trading. It's all it is just trading. If I did this, this is 5. 1, 2, 3, 4, 5, and then we would trade that into this. That's what we would do. Yeah. You know, Kyler, the reason why I was like stuck a little bit because I thought it was an acronym for something, and I'm like, I don't know a lot of acronyms because I'm old. I just found out what NGL is, and then I was trying to look at the other one was uh, PMO, and I'm like, what's PMO? I was like, oh, really? So, yeah, I don't know acronyms. When we go back, okay, so what we're doing is when we move the beads, we're going to move the one bead. We want to know that when we move the bead up, we go to the horizontal bar. When we move down, we're moving it away from the horizontal bar. Now we're doing a subtraction. When we add, we go to the horizontal bar. When we subtract, we go minus the horizontal bar. Right? We go away from the horizontal bar. So here, when I have 7 and I want to take away 6, I want to move it away from the horizontal bar. So my final answer is 1. Let me know could also mean put me on depending on the area. That's I don't. Oh, ha ha. How long did it take you to learn how to read the abacus and use it like a calculator? It probably took me a few weeks. But but I had to do it out of necessity. I had to do it because my dad wanted to open up a business. And so we opened up a learning center out in California. I'm in California. If anybody wants to learn how to use the abacus in person, I do have a learning school. And so we've been in business for about 20 plus years, but I decided to put it onto the internet. Um Oh, put me on. Oh, interesting. I see what you're saying. I see what you're saying. Um, yeah, I'm in Monterey Park, so I'm in the San Gabriel Valley, and we've been around for 20 plus years, and we teach children from 5 to 10. I would say about 10, 11. The reason why is because right around 11 is when they get really busy, and when they get busy, they don't have time to do abacus. Also, the attitude kind of sets in. Yeah, yeah, here I'm teaching adults. Oh, here I'm teaching adults. And so I have books if you would like to practice. You're in San Diego. It's like 3 hours away from me. You are in San Diego. I'm in Monterey Park. I'm in LA. Oh, so yeah, I do. Yes, you're right, boss. I do teach. I'm teaching adults, and now it's like a hobby because, oh, Florida. Yeah, I have a bunch of friends in Florida. I have a couple of students out in Florida as well. I do have an online class where I teach abacus, and they're one of them is 4. And that was the other thing is I'm going onto the internet, and I also want to focus in on the younger kids, so like 3, 4, and 5. But I noticed that now, even adults or older kids, they're like teenagers. Even the teenagers. Hey, Florida. Oh yeah, teenagers, if they're open to learning something new, I'm open to teaching with them, but I don't handle well if there's attitude, you know what I mean. I apologize, I heard you were from San Diego. No, not San Diego, it was oh, not San Diego, San Gabriel. I'm in the San Gabriel Valley, so I'm really close. There was the Pasadena fires. I was like 4 miles away from the Pasadena fires, so that's how close I am. Yeah. And so yeah, when we talk about it, we want to make sure we understand how to move the beads. So what are the questions would be? Why am I? Whoa! When does it happen to utilize? What happens is when we know if there's enough beads, we can add it. So what we're going to do is we're going to add the beads, right? Can we do it? Yes, we can. We're going to add the beads. The question is when we have 3, I want to add another 4. If I want to add another 4, there's not enough beads to add the 4. This is where we come into understanding the formula. Let me get my book. So yeah. So if you notice, my question is 3 plus 4. Because I have 3 plus 4, we're teaching the children how to do this. We're teaching the children how to plus the 4, plus 1 and 4. So when we're teaching the children how to do this, the idea is, what is the idea? The idea is that we're going to manipulate it. We're going to isolate the variable. We're going to isolate this variable. To isolate the variable, right? Here's my question. I'm going to have 3. When I have 3 on my abacus, I have 3. I'm going to do 4. When I add the 4, there's not enough beads to add the 4. Look, I only have 1 bead. So we're going to take this information. We're going to change it, right? To change it, we're going to do plus the 4, plus 4 is equal to plus 5 minus 1. So this gives me direction. This gives me a little mapicus. Plus the 5, take away the 1. So my final answer is 7. So what we're doing is we're understanding that if I don't have enough beads, I have a little bit of constraint. Because I have a constraint, I need to be able to plus the 5 minus the 1, and then my final answer is 7. We can do it again for the plus 4. When we add the 4, we're going to show on the abacus to plus the 4. When I want to add another 4, I'm not going to memorize our doubles. We're not going to memorize doubles. What we're going to do is we're going to memorize the formula. This is directions on how to move the beads. So what we're going to do is we're going to plus the 5 and we're going to take away the 1. So my final answer is What's my final answer? Please put it in the chat. 8. Thank you. Thank you, Enrique. So I hope that makes sense. Hello, Memphis. Okay. Cat, are you still sleeping? Because I see cat. Zzz. Z, are you okay? Everything's okay? Balls, how are we doing? 8 plus 3. Yes. Yes. 5, 6, 7, 8. Yes. Exactly. And so what we're trying to do is we're trying to understand that when we take this 4, we're going to substitute this formula. I was making coffee. Oh. Okay, good. As long as I'm not putting you to sleep, then I'll be happy. All right. All right. What are we doing? What are we doing? Are we going to continue on? We can continue on. Like, but this is like fundamental. This is fundamental stuff. The reason why, where did I get my mug? Disney? Winnie the Pooh? But you know how old this is? This is like 26 years old. I can't even read the thing anymore. Yeah, this is, thank you. I appreciate that. Yeah. We I have yeah, thanks. I I don't think that they sell this anymore. Please continue. Let's learn the fundamentals. Oh, okay, great. Okay, we'll do that. Okay. Yeah, see, that's the thing. Like, everybody's like, I want to know multiplication, division. It's like, well, hold on. I'm okay with talking about the fundamentals because it's really quite interesting. I think it's underrated. So if you if you ever want to get rid of it, I'll buy it. uh, no, sorry, sentimental, because my husband and I we have matching ones, and so at the time I really liked Eeyore. So yeah. Anyways, yeah, that's not in my TikTok shop. All right. So you know what? Okay, good. What we're gonna do is, what are we gonna do? Okay, let me. I have my. Okay, I'm sorry. I'm trying to think. Like, I have a book. Let me see if I can show you. My new book is about minus the tens. No, not minus the tens. It is how to how to minus the fives. So this is the new book that I'm going to publish, but I didn't publish it yet. Add it to your TikTok shop. Yeah. I feel like I'm learning math all over again. You know, that's the funny thing. When I was learning the abacus, I did feel like I was learning it all over again. And I was like blown away on how abacus made it so easy. So we can talk, you know what? Let's do that. Let's go through this book. And then we can go through the next book. I just got to print it out. So this is one of the books that's in the shop. There is the preschool one, but depending on who's it for, I meant this one. This one was for meant for kids. Oh my god, these are your yeah, these are mine. How did you manage to learn the abacus in a few weeks? Are you self-taught? No, my dad. What my dad did is he found a franchise and he bought the rights to it, but that was also like 20 plus years ago. And then from there, oh yeah, and then from there, what I did was they talked to us. So my links in my bio. If you ever want to catch me on YouTube or anywhere, if you want some worksheets, I have some worksheets on my website or on Teachers Pay Teachers. I do. This is me. Hi, my name is Lynette. Um, I am trying to add more books to the TikTok shop. It just takes time. But yeah, these are mine. I do sell the abacus as well. I do have this one, and then I have this one, and then I I'm I haven't been carrying inventory because I'm just very new to TikTok shop, but I do plan on carrying some more inventory. Depending on how, I didn't know that this was going to take. I didn't know people like it, so I didn't think about getting my TikTok shop up and going. So okay, so going back, so This is for preschoolers. My idea was that these would be for young kids. That's why there's activities for the kids. And so these activities was to like follow the path. And this was more of a, was it like a maze? And they can choose any which way to go. It wasn't to be too like stringent and stuff, but the idea was to get them to practice their coloring and their penmanship and their motor skills. So here is and this is about bead recognition. And because we did bead recognition, then we like count forward, we count backwards. So we have this, and then finally, we have the adding and subtracting towards the end, right? So that's what we were doing, is how I was showing you how to move the beads. And we were just talking about how to add and subtract. I do have a new book that just came out. I do have a new book. If you're still worried, not worried, but if you're still in if you're still wanting to talk about how to read the abacus, what I did is I do have this abacus mazes. This is only 2 digit, but I do planning on do 3 digit, 4 digit, and 5 digits with the decimal. And so this one is also available at the shop. At the shop, I just published this. And so the idea here was, you find what the maze is, and there's a little mask. And what we can do is we can figure out what number is this. So on the abacus, what number do you think this is? So in the chat, let me know what number you think this is. If I mimic it, so what we're doing is we're doing a bead recognition. We're going to do this and we do that. Please tell us the backstory from learning and lead us to this amazing moment. 52. False? No, it's not 7. And it's not 12. 12 looks like this. 7 looks like this. 52, Enrique. Yes. So, well, okay. So then what happened was, but that was like 20 plus years ago. And this was before I had my 3 boys. I have 3 boys and they all gone through the abacus curriculum. And so, working full time and then having the school, it was a little tough because we would only be open on the weekends. And so my dad decided to finally retire, and then my brother was going to take over the learning school, and then I decided to go on the internet. And I decided to actually create more workbooks and worksheets available for abacus. And all of my stuff is abacus specific. So when I'm doing this, it's all about abacus in mind. I try to make sure that it is structured. So here I have the plus the 5. When I'm adding the 5, I don't have a table of contents. I didn't think I needed it, because I was imagining that everybody would go through page by page, because the way this is built is we want to add the 4. After we add the 4, we want to add the 3. Right after we add the 3, we want to add the 2. So then again, this is about being very systematic in a framework. um Systematic and framework. And then after you finish like after you finish understanding how to make a 1 and so forth, then we can go into making the maze. So there's a maze, and then there's word problems and the hidden word. So there's activities to strengthen the concept of how to add a 5. So this one specifically is how to make a 5. And I try to add in number bonds because I was trying to relate it to mainstream school, so the kids know what it looks like. And this was just a number line, but this was to keep score. And I was like, again, it wasn't meant to be abacus specific for the number lines and the number bonds. It's for this one was trying to be for you, for the youth. Yeah. This one was like, in my mind, I was thinking that only kids that are young would be going into this. I didn't know adults would be. So I'm actually in the process of creating an abacus book for adults, but it still have some of the same activities, like this maze over here. You can find out what the answer is as we do here. So we have two, and then plus another 2. And then what I want to do, I want to plus the 8. I'm sorry, plus the 3. There's not enough to plus the 3. What do? Plus the 5, take away the 2. My final answer is 7. So then I just follow the path. I love how passionate you are about this. I do. I do feel like it's one of my passion projects. And this is a maze that I did. And this is what it's to look like. And then I have tic tac toe just to get it entertaining and interesting. and then and word problems. But I think in the adult one, I'm not going to do word problems. And then afterwards, there's all these answers. No cheating. That's amazing how so advanced and very impressed you've come up with the books that teaches. Yeah, there's a few people that bought it and they were very impressed on how much explanation I put into it. And so when I was trying to do it, I made it so then yeah, I made it so it's self-explanatory, and I tried to have like instructions, and then I have my second my the second one is still being published. This is going to be the fourth book, and this is talking about the plus tens, and this is only specifically about the plus tens. And that's what we were doing is we were talking about how to add a nine, and it goes all the way how to add a one. And then I have the practice pages, and after the practice pages, then we go into puzzles. And this one was kind of cool. You answer the puzzle. This is the puzzle board. You answer the puzzle, and then you find the answers here. You find your answers, and then you match it, and you kind of see what the picture looks like. Yeah, yeah. I'm trying to make it fun for the kids because I noticed the abacus books that are out there are very boring. So this one is about solving the problem. Find the hidden word. So you answer the question and you just try to match it to the word at the bottom. And yeah, a lot of the questions. So yeah, and I have this one that I just recently done, and this one is extra problems. If you wanted to practice like extra problems, what I did here was I broke it up into specific numbers, and every number, every question has a number 8 in here. So if we did this one right, and we want to practice what it would look like, it would be 3, and then I want to add the 8. When I add the 8, it's plus the 10 minus the 2, and then it's plus the 1, and I add the 1. So my final answer is 12. But again, you're filling with your enthusiasm. It's amazing. Wait, thank you. I appreciate that. But see, the thing is the questions I have here are very number specific, and I think that's what we need to do in school. I think the numbers need to be specific because this you can't tell what the result is, right? I mean, you could see it because it's not that much, right? But in abacus world, we actually have like 10 add-ins, and you can't tell. You can't tell what the result is. So I don't understand why we teach the kids to know what the result is as opposed to what the add-in is. It's better to know what the add-in is. So you see that when I'm trying to add it, then we know what we're doing. So this is my practice book where it goes all the way to 1, and again there's answer sheets. But no cheating. But it only goes up to plus the 1. Yeah. You haven't been on what? I've been itching to watch Really Dolce. Honestly, I think it's the hardest thing about the abacus is remembering one number in itself in equation. Yes, yes, and you know what, boss? It is about a different shift, and it's a different mindset, right? Because we were so taught in school that we need to know everything, but in abacus, you just take it one step at a time. Dolce, welcome back. You make it sound so easy, but the process makes it look like rocket science. Abracadabra abacus. I'm gonna make that into a I'm gonna make that into a sound bite. I love it. I love it. You know what? It is really easy, but you take it one step at a time, and it goes back to attention to detail. And so I'm actually on my ninth book, which is crazy. I didn't think I was going to be this far along, but I honestly, so you guys know, like full transparency. I mean, I just started doing this online thing recent, maybe about a year. Abracadabra abacus. And so it's refreshing to be able to talk to parents and to adults, to even who are interested in learning how to read the abacus, because now I've become there's this new, it's inspiring, and it sparks creativity to be able to talk to you guys. Ninth book, the ninth book, you have a lot of knowledge. And you know what? I don't know if it's a not. Thank you. I appreciate that, but I don't honestly think it's. I don't see. I don't because I know it. I don't. I don't. I don't. What I'm trying to say. I don't get it. So like this, I've just made this. I made this because of you guys, like because of my lives. I made this thing, and so I'm actually putting this into another book. So this is a laminate that I'm going to put into my TikTok shop, and this would be a study tool for parents to help the kids to. And again, it goes back to helping the kids because I think about the kids, but I don't think that the adults would want it. You know what I mean? Like I So it was like kind of crazy, like just going through this process of like talking to other people. And it's just amazing. This is why I really love TikTok. I mean, I'm so appreciative of having TikTok. It goes to show there's always something new you could learn. Or for me, it's the abacus. Yeah, yeah. And it's really amazing. Like, I still learn, but I learn what I'm learning is how to explain it better, right? Because I have a lot of people that are like, I don't. I mean, you've seen it. They're like, I don't get it. And I was like, that's okay. We can do it again. We can review. But the idea is to, slowly go through it. And I notice that I have to. I talk too fast. I know I talk too fast, or sometimes I jump thoughts because to me it made sense. Like how to move the abacus, like it makes sense to me, right? How to move the abacus, just use the edge. But the funny thing is people are like, oh, and I'm like, huh, okay. So there's a lot of things that I forget, but I try to remember, what it was like. And that was, I think that's the difference between, I mean, I've been dealing with abacus for 20 plus years. And so I didn't get it either until you explained it easy. It makes it easy. Yeah. And that's the interesting thing about it. Like if you go to any other videos on YouTube, they talk to you as if you already know what's going on. They talk about big friends and little friends and all these other people, and it's like I don't know why. And there's not a connection to like what we're trying to there's not a connection between what we're doing in mainstream math and how we're doing it in the abacus. And I think that's what makes it different. And also I think I'm here to flood the market with all my abacus activities. They're so confusing, right? Yeah. I mean, and they're like talking about, and then they don't have labels. And I think that's the other thing. So I have labels. I got labels. I'm labeling everything. If you don't like to be labeled, you're not in this room. So that was the thing is I made these labels so then people can kind of understand. And I was like, oh, this makes so much sense. But I think that's the thing. Like, I, you know what it is I think what it is in the abacus world, we were always taught through verbal, and we were not taught through paper and pen and diagrams and stuff. So if you guys are interested, so this is my big brain notes. If you want this, it's available in my website. Go ahead and you can download it. You can download it from my website. So the link's in my bio, and from here you can. It's just a simple like how do you read the abacus? It's a simple form, not a simple. It's a chart. It's a reference sheet. How to do it, and this is for free. You can have this, and I made this too. You can't find this anywhere. So this is talking about how to understand place values. That's it. So, and I have more. It's just, going through TikTok, it's just amazing. And I feel so invigorated and creative. And I hope that it works out. I hope it works out. So we'll see. There's many others. It's really quite interesting. Like I have so many worksheets. I got to do is I got to put in the time to put it in my TikTok shop and then just build it out. Because I follow some other like homeschooling people because they're as entrepreneurial, and so they have like a bunch of things too. Just teach the labels. Just the labels. It teaches you a lot. Yeah, exactly. Right. And so that was the other thing. Like, um, yeah, I think that's what it is what abacus does in the world of abacus. I think we lack labeling. So here is an old school abacus, just so you know. I got my further going. Yeah. Here here's an old school abacus. You see this all the time. You see it everywhere. But I was like, wow, that's really boring. It gets mind numbing after a while. And so I'm like, there's gotta be a better way. And that's why I have my worksheets. So but the extra one is just because people just want to practice. But then this one is about uh talking about the cats. Yeah, the puzzles make it fun. Yeah, I think so too. I think the kids enjoy. I think everybody enjoys puzzles, and I think it's too bad. And that was the other thing. Um, so this one here, I added a little bit towards the end where we can find out what the number is, which is good. But then here I added where you have to do. It's called a reverse abacus, reverse maze. You have your number, right? We start from, where do we start? We start from here. You have your number and you have to color in, and I think coloring is coming back. So you're going to color in the number of the beads. So this is going to be 68. So you would color in 60, 5, 6, and then 8, 5, 6, 7, 8. And then you do it again. If I have 20 here, I'm going to color in 20, 20, and then 24. I do 1, 2, 3, 4. And so I was trying to get it to be more interactive um, as opposed to just like, you know, what do you call it? Just moving the beads and stuff. I want it to be more interactive and be more, yeah, be interactive. That's what I like. I like being interactive, but I do appreciate everything. Yeah. So the puzzles, and then again, the answers are in the back. But there's only two sets. One is the regular maze, and then the next one is the reverse maze, is what I called it. And then if you wanted extra, I do have extra mazes available if you want. There's a QR code I added, and there's an explanation. So here's the explanation what the reverse maze is. So what it is I give you the answer, and then you have to color in the thing. So I'm trying to be as give you a better explanation as possible, if that makes sense. So that's what it is. So what I'm trying to do is it also helps that I have conversations with you guys. But thank you. I do appreciate it. If anybody is interested, I do have my store. I'm trying to build out my TikTok shop as well. So that's everything. Oh, and that was it. Yeah, there's these flippy thingies. These are my flipping formulas, and it's the same thing where you would have the minus the 2, it's minus the 5 plus the 3. And so when you look, I want to do, I don't know, 7. No, not 7. I want to do 6. I want to do 6, and I want to take away the 2. When I take away the 2, what do? Minus the 5 plus the 3. So I minus the 5 and I add the 3. And then my final answer is 7. Sorry, 4. 4. 1, 2, 3, 4. So that's what these are. These are the flippy thingies. And if you know these, add the 5 minus the 5, add the 10 minus the 10. If you know these, then you know how to add and subtract everywhere, which is really interesting. And this I haven't put on my shop yet, but I will. And the thing is, I haven't put it on my shop yet. I have to figure that out. The reason why, because this is a digital download. This is available on my website, but I haven't. But if I was to make it, I don't know how to make it, because it would just be a piece of paper. I'd mail you a piece of paper. So I don't know. I think that this what it's called, the formula flippy thingy. Flipping formula is what it's called. The flipping formula is what it's called, and it's available on my website. It's a digital download. It's available with your yeah. This is available on my download, and also I think I put it on Teachers Pay Teachers, but I'm not sure. But yeah, yeah. So I mean, that's what it is. Is it's inspiring to talk to everybody about it. But thank you. Can you? You know what? I don't think you can do a digital download on the TikTok shop. I think you have to go to my website or you go to Teachers Pay Teachers. Because I was trying to figure out how to do it on the TikTok shop, and I don't think you can. Um, I would like to. That would be great. But I think I noticed that everybody sends everybody to like their stand store, their stands store or whatever, to do digital downloads. So I don't think they can do digital downloads in the TikTok shop yet. But that will be, hopefully TikTok is hearing, and we'll try to get the digital downloads would be cool. Um yeah. But yeah. Wow. That's a conversation. I've never really gone that deep into like who I am and stuff. I've always talked about just the questions. But thank you guys for participating. I do appreciate it. Is there any other questions? Um yeah. I actually have to go through my new book. I love listening. Oh, thank you. We're glad you shared it with us. Oh, thank you. I appreciate that. I just yeah. No, thank you. I appreciate, having somebody to talk about this. It's been a while, right? I mean, in the beginning it was like kind of I didn't know what I was doing, obviously, right? Who knows what they're doing in the beginning. But, what like yeah, because my original thought was I was only going to talk to parents that was interested in learning the abacus. But then as I go through all of these lives with everybody, it's been very interesting that I'm actually in the process of building out an introduction for adults, and also doing multiplication division on the abacus. We're getting to know our magician teacher at a personal level. I appreciate that. I appreciate that. Um, yeah, yeah. It's been interesting. Like I was trying to figure out, like, yeah, the one problem that it's the time to curate all of the questions. I think that's what it is. And that's what's taken me the longest time, is to be able to curate all of the questions, because the questions, if you notice, are very specific, right? Here's another thing that I made. So what we just did is we talked about the simple, right? Is there enough? Yes. Yes, there is, right? This is Bob the Builder section where we have 2 and we have the 5. We can do it. So then what's next? Well, this is what we do, the plus fives. This is the plus fives. Is there enough? No, there's not. But how do we do it? We have the 3, we want to plus the 4. We plus the 4, we add the 5, and then take away the 1. We add the 5 and take away the 1. Then what do we do? Then after that, we have the tens. This is the plus tens. Because this is the plus tens, can we do it? Well, no, we got to use the tens now. So if I did 7, I want to plus the 5. Plus the 5 is what? Plus the 10 minus the 5, right? So our answer is 12. So then there's this little white part here. This is where we talk about the two-step equations. And that's when we were talking about, this is when we talk about this stuff here. It's a two-step equation. That means I take the adding of the 5 and adding of the 10 to a whole new level. And so it's like, that's what it is. It's like, it's a game, right? Every level you get to know. Bob the Builder was my favorite show growing up. Oh yeah. my my uh, my boys were not, my one of them was really interested in Bob the Builder. But then I think the same one was really interested in Ninjago. I haven't figured out how to say anything in Ninjago, but then everybody was really interested in Pokemon. So um that's where I got the choose any one of these dots. I choose you. um yeah, Bob the Builder. That one came up, and then Tokyo Mater comes in my head a lot. So that's what, and if you notice, it's all about the patterns. You either like Bob the Builder or Handy Mandy, knowing to be, oh, that's interesting. Really blow out of nowhere. Yeah, Pokemon just came out of nowhere. Um, Handy Mandy. We never. Yeah, you're right. I never got into. We never got into Handy Mandy. My kids didn't get into Handy Mandy. They kind of like Bob the Builder. What else? Oh, we really liked Nihao Kailan. I liked it because of the whole cultural thing. Because I don't have a lot of. There's not a lot of Chinese stuff out there, like for kids. That is English based. But we did like that. Funny thing, I like them both, and they're the same. Oh, interesting. Yeah, I loved that show when I was a kid. Yeah, you guys are lucky. You guys didn't have commercials like we did. Well, actually, no. Kids now understand what commercials are. There was a time where the kids, hello, Neon Panther. Did the birthday party over? Welcome. My cousin used to watch that and even just speak about everyone thought it was, until I watched the show. That's funny. Until it was gibberish. Gibberish. You talk gibberish. That is hilarious. Oh, yeah, yeah. It's just interesting on how, like, it is about representation. Yeah. Oh yeah. Gen Z had commercials, streaming services came out, yeah, when we were teens. I had commercials. It was great because it allowed me to grab, yeah, right? But see, the thing is hello, hi, cat. Yes. I Why are you on? Go to your party. Enjoy the moment of the birthday party, not be online. Enjoy the moment. When I'm like at the track meet, I kind of see, but I don't go live anywhere. Yeah. She's picking up super fast, even when she meets the president in fifth grade. Whoa, that's fantastic. Meeting the president. Sorry, I'll leave. No, don't be sorry, but you need to enjoy, everybody else. You need to enjoy the people that's around you. I'm on level 3 gift kids. She's on level 5 in 10th grade. That's interesting. Enjoy the moment and grab seconds with cake. Yeah, right. Enjoy the moment. I'm here often. Come on. Go. I'll see you later. See you later. Yeah, go enjoy your life, not online. Online is not where to be. You have a place to do, go do it. And that reminds me, I am going to sign off really soon. I'm kind of winding down now. But thank you everybody for joining. Bye, Neon Panther. Can you do 5 plus 9? I'm trying to see if I can get that right in my head. Yeah, yeah, yeah. Let's do that. So we have, which is here, we have 9. Let me do 9. See you later, alligator or abracator. Abracator. I don't know about that one. I don't know about that one. So the question is 9 plus 5. When we look, we have the question is 9. When we add the 9, right? What are we trying to do? We're trying to plus the 5. We do not have any beads to plus the 5. To do that, we have to do is plus the 5. Um there we go. Sorry, I'm looking for my papers. 1, 2, 5. Where did it go? Did I move it? Yeah, there we go. Is it here? No, it's not here. Oh, here it is. Here it is. So we want to add the 5. We know when we add the 5, it's plus the 5 is equal to plus the 10. We know that, right? So what we're going to do is we're going to isolate the variable. When we isolate the variable, we take this and we isolate the variable. Why? Because the question is 5, right? When we do that, we need to, sometimes it helps to do this, right? Sometimes it helps to do this. Plus 5 is the original question, and then we need to minus the 5. I don't know if this helps. I'm just testing it out. So here, I'm going to minus the 5. Notice this 5 and this 5 is minus. Whatever, because what we're trying to do is we're trying to isolate this variable. Now, because this is the 5, we're subtracting, this becomes 0. So when I rewrite it, I do 5 plus 0 equals to 10 minus 5. I'm doing step by step, if that makes sense, right? So I'm going to rewrite it again. I'm going to do 5 is equal to plus the 10 minus the 5. So now I have directions. My question is 9. I have directions. I want to plus the 10 and minus the 5. So I'm going to minus the 5. I'm going to plus the 10. Remember, 10 is 0 and a 1. 1 goes here, 0 goes here. So I'm going to add the 1. And my final answer is 14. Does that make sense? So my final answer is 14. I don't know if that's too much. What does isolating the variable means? Isolating the variable means make it by itself. So I was trying to use algebra terminology into abacus. That's what I was trying to do. Because you will isolate the variable in algebra. When we look at algebra, it looks like this. X plus 5 equals 10. So this is a variable, right? We don't know what this is. But what we're going to do is we're going to make it by itself. We're going to isolate the variable. When we isolate the variable, we're going to do x equals plus 10 minus 5. So what we did is this is what isolate the variable is. We make it by itself. Does that make sense? Hello, coin purse. Welcome back. Don't spam. Or I will have to block you. Yeah. Yeah, not a problem. These are questions that you need to ask. Why? Because I don't know what you don't know, right? So I mean, every teacher is obviously different, but I can how are you going to know if you never how am I going to know what? How am I going to know how to explain it to you if you don't ask me questions? I love these. Please don't block me. Okay, good. But don't tell people to like get some, I don't know, coins or whatever. I still don't get it, but I guess I'll keep watching your lives. Okay, Dolce, hold on, hold on. Let's take a look. So what we're trying to do, let me think about it. I'm a whiz at algebra, so I really get this part. Yeah. Let me see. Okay, I have to think a little bit. Okay, hold on. I know what. Oh, you know what? We'll do blocks. We'll do blocks. My name is Penny, so I thought coin purse was a funny. Oh, you know what? You have to be careful because somebody would come spam and say, join, take, uh, uh, sign up for getting some coins or whatever. So you have to be careful with that one. But that's interesting. That's what I thought. Because there was somebody that came into one of my lives and be like, yeah, if you want these coins, because it was like TikTok coins or whatever, and they're like, if you want these coins, go follow me over here, and I'm like, what? That didn't. So that's what I thought. So be so be careful. Okay, 9. Let's do this. One, two, three, 4, 5, 6, 7, 8, 9. Okay, you want to do this? We're doing this. We're doing this. I don't know. Let me think about it. I have to think about it. I have to think. Let me think. So, because what are we trying to do? We're trying to add the 9. We're trying to add the 9. Oh, yeah. One, 2, 3, 4, 5. Okay, we're trying to add the 9. So, what are we doing? We're doing cat. What does your bio mean? Okay. So, what are we trying to do? We're trying to add the 5. Oh, I got it. I got it. So, maybe this is better, right? We're trying to add the 5, but I only have this 10. Dolce? I want to add the 5, but I only have 10. What do I do? I need to add the 5. 10 is too much. 10 is too much. So if 10 is too much, I have to trade. I have to trade it in. That's what it is. I have to trade it in. I'll take this out and I put this in. Yes. 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 Because we're trading. So we got to take this out and I take this out. Subtract. My mommy forced me to watch. Pikachu! Pikachu! Pichu! Not Pikachu. So does that make sense? So what we're doing is we're trading. We're trading in the 10, right? We're trading in the 10 and we have to take away the 5 because adding the 10 is too much. Does that make sense? How does this look on the abacus? Oh, so we have 9. The question is 9? I'm sorry. The question is 9. I want to plus the 5. Plus the 5 is what? Plus the 5 is plus the 10 is equal to plus the 10 minus the 5. So this is what we're doing on the abacus. So we have to plus the 10 and we take away the 5. Dolce, did that make sense? What we're doing is we're trading. We have to take away the 5. We have to remove it. Because if we add the 10, it's too much, right? I think it makes sense at the same time I feel lost. That's so cool. Yeah. See? We want to add the 5, but we can't We cannot add the 5. So we're going to add the 10, but that's too much. Now we have 19, right? Now we have 19. We're adding too much. We have to take away the 5. That's what it is. That's what it is. What we're doing is we add more, and then we have to. When do we do that? We do that for we do that when we do that with money, right? We do it with money. I don't have a lot of money. I just have my pennies. It's the same concept. If you have 4 pennies, right? And I only have 1 nickel, but I want to trade it in. I'm going to give you 4 pennies, but I don't have any more pennies. I don't have any more. I only have a nickel. So what I'm going to do is I'm going to give you my nickel, but you got to give me back a penny to replace it. So my answer is 8. That's probably what it is. It's the trading in. This plus the 10, we have to trade it, but that's too much. So we have to take it away. So we're shaving off a little bit, if that makes sense. Yeah, I think that's what it is. Maybe that way, maybe that makes more sense. Yeah? Okay, good. So sometimes money helps, right? Sometimes using money, yeah. Because we do, because we do it so often, right? We know when we're trying to buy something, it's like 17.99 and I only have 20 bucks, right? It's the same thing with the 10. If you have 9 and I give you $10, I want it I only have $10, but it's worth 9. What do I do? I take Wait, how do I do that's the question is what? I want to I only have $10, so you're going to have to give me $5 back, right? So you have to give me $5 back. So you have to take away the 5. I don't know how to say that one. That one kind of like I have to figure out that money thing. So, does that make sense? I hope that made sense. But that's the thing is like you're trading it in because I only have this one thing, right? And it's interesting because yes, abacus doesn't translate that well if you don't understand that this is a tens. But notice this formula, this formula right here, it's actually position agnostic. What does that mean? It is position agnostic. Let's continue. So we do 5 is equal to plus the 10 minus the 5, right? We know this. Well, what happens if we did 900 plus 500? How you come up with great explanations out of nowhere. That's amazing. It takes, yeah, I don't know. That's why it makes me so invigorating, um to be able to be creative about it because that's what teaching is. Teaching is about communication and making the other person understand. And that's what I feel. I believe in my heart and my soul that teaching is about how to explain so you understand. So here is position agnostic. This is 900. I want to add 500. 900. I want to add 500. But I am not going to say 500 is equal to plus 1000 minus 500. I am not going to say that. That is way too much. What I'm going to say is plus the 10 minus the 5. Why? Because if you just take the column by itself, like this. Oh, what am I trying to do? I'm trying to add the 5. How do I add the 5? Minus the 5 and then plus the 10. That's all I'm doing. So then you come back and you be like, oh, it's 0041. Position agnostic. I'm gonna trademark that name. Position agnostic. So that's why we were very careful not to say 500 plus 1000 minus 5. That doesn't make sense, right? The numbers are too big and your brain can't wrap around it. Why? Because we don't look at it as a whole. We don't say this whole thing. We only want to focus on the one column. Does that make sense? Dolce, are you still there? So we're only focusing on the one number. We are recalculating. Yeah. Yeah. So that, and once you get the foundation, once you understand this, it actually doesn't matter where you are in the grand scheme of things, trying to process what happened. Yeah, it does take a little bit, but it's a little bit of reworking, because we're teaching when we teach the children, we teach them this way, right, with the zeros and stuff. But with abacus, we only focus on the one column. We focus one column at a time. Abacus makes it into manageable chunks. Abacus makes it into manageable chunks. And that's what it gets really amazing, like when you get into multiplication and division. Thank you guys so much for the hearts. But yeah, it's really quite amazing, like how manageable the chunks get. Like when we're done with this part, and it's not going to be today, but when we're done, when you understand this part on my next lives that we go forward, I go all the way to division. And division is where multiplication, division is also where it gets exciting as well. But I like adding and subtracting because I see that there's a lot. I feel like adding and subtracting is underrated, right? We always want to push the kids to do fast math and to do it in their heads, but I think a lot of it is, just understand the fundamentals, understand the basics, understand, because when you know how to wax on and wax off, then you'll be able to do karate, right? That's the Karate Kid thing, right? Learning the fundamentals, I think, is underrated. It's more powerful than than what is perceived. One, two, three, four, five. I think I need to make another one of these. I gotta make another one of these. But yeah, I do appreciate everybody still here. I mean, this is amazing. It's amazing that you guys are still here. it it truly is. I do truly appreciate you guys taking the time to understand this. And I hope that when you have kids, if you have kids, that you can teach them this. Because I truly believe it's the greatest thing next to sliced bread. My kids did not have a problem with math. They do have a problem with reading. But it's also because, having being young and stuff, right? It's just one of those things. Dolce. Oh, I would truly appreciate you teaching us. Yes. Oh yeah. So I'm hoping that makes sense though. Like we'll want to trade it in. I don't have I guess what I could use is I could use a dollar bill. That's amazing. Thanks for taking the time to teach amazing stuff. That was me too. Yeah. No, I appreciate you guys taking the time to like learn. I mean, who wants to learn math like one in the middle of the night? Because when I'm in the middle of the night, I get like a bunch of people, and then two, like even in the middle of the day, you're taking the time on a Saturday to learn math. I'm like, what? You guys are crazy. But I appreciate it. Don't get me wrong. I appreciate you guys are learning something different, right? You guys are learning something that's, that it makes math, doing adding and subtracting really easy. And I'm just trying to show you an easier way to do it instead of doing memorization and doing what do you call it? Instead of memorizing and learning the strategies, there's a lot of strategies. Oh, it was annoying. It was so annoying when I was like listening to the strategies. I'm like, no. So, but yeah, I mean, yeah. So I do appreciate you guys staying the time. We can do it some more. I mean, but does this make sense? This is position agnostic. We want to make sure that it understands. Math has always been interesting with the right teachers, and you, ma'am, are the right. Oh, thank you. I appreciate that, Afro Mexican. 23. Thank you. I appreciate that. I do. I do appreciate it. And it is a lot about the teachers, and it's never really been about the schools, but obviously the schools, bring on the best teachers, um but it also depends on whether or not the children understand, right? And that's the thing. I want to make sure you guys understand, right? And that's the reason. So, but thank you, Dolce. I appreciate that. but I hope the trading makes sense, because it's not math is not meant to be the math. Interesting. Math is about patterns, and we don't teach patterns in school, which is very interesting to me. So, but is there any other questions? Do we want to continue on with this? We can do more trading if that helps you. Um, uh, but you know what? I am going to sign off pretty soon. I am getting a little bit tired, and I need to publish my book. I'm going to publish my book. Oh, I need to do the thing. I'm confused, but you make it fun learning. You're confused. What are you confused about? Can you do 8 plus 3? Yes, let's do 8 plus 3. I like the questions. Uh, Enrique, you have to tell me what question you're confused about. What are you confused about? We do 8 plus 3. Um, Here is a thing. Is this one? No, not that one. I'm trying to find. Oh, please. Trying to find. Here. Okay. Here is the framework that we're going to talk about. The reason why I bring up the framework is because there's two equations for 3. What does that mean? If I want to add the 3, right? If I want to add the 3, I can either plus the 5 minus the 2, or I can plus the 10 minus the 7. So there's two ways to add the 3. That could be the problem, right? The problem is what? Which ones do we use? Because if you look, they're adding at the 3, but there are different ways to get there. So the question is 8. I'm going to add the 8. When I add 8, I want to add 3. Now, here's a little framework that I created, and this is the process that goes in my head. Is there enough beads? Yes. Then add the beads. So the question is 8. I want to add 3. Is there enough beads to add the 3? I'm confused in general since it's my first time learning about the abacus. By a little bit. Oh, I see. Yeah, yeah. It takes a little bit. It takes a little bit of time. Um, so we don't have enough. So we're back to here. We want to go to no. The question is can I use the 5 bead? Yes, then do it. Add the 5. No, I can't add the 5. So I'm going to go down. Can I use the 10 bead? Why, yes, I can use the 10 bead. What is it? Plus 3 is equal to plus the 10 minus the 7. So I'm going to plus the 10, and I'm going to take away the 7. My final answer is 11. Does that make sense? Is that better? Because now we have it in a little framework. So now we understand, like, these are the questions that are asking, right? And this is what starts with critical thinking. Critical thinking is, can we do it? No, we can't. So we come down. Can we do it? No, we can't. So there we go. Do you memorize those equations? Yes. Yes. I memorize the partners is what I do. Do you memorize it? It what did it make that did make so much easier to understand. Yes. So when what? When I was learning, we were taught the partners. I think that's where I get confused when to use. Yes. But notice it's only for these two. It's only these 4. These are the only 2 that has 5s. There is no second equation for the plus 5, and there is no second equation for the 6 or the 7 or the 8 or the 9. There's no second equation. However, if you look, if I open it up, you'll see that there's a minus 4. The minus 4. What? So now we're back to here. Can we minus the 4 plus the minus the 5? Or this is where it gets interesting, right? This is where we start combining. This is why we need to memorize the partners. And it all depends on what we're trying to do. So if I'm trying to minus the 4, I can either minus the 5 or I can minus the 10. So I got to memorize the partners. Yeah, that throws me off. Yes, yes, memorize the partners is what I think. So do you see that there's a difference? So what we did is we substituted minus 4. Minus 4, can we do it? Yes, we can. If we cannot, can we add the 5? Right? So now this is Tetris. Now we're talking about Tetris, right? You know how Tetris goes, right? We have these blocks and they're very specific. Like this. I don't know. Whatever. They're very specific. Hey, Cool Whip, welcome back. Because the blocks are specific, that's what these are. These are blocks. These are specific blocks. Well, yeah, these are specific blocks. So it all depends on how it fits in. So it's is it it is more advanced thinking, advanced adding, because now we have to really critically think. Can we do it? And that's why I keep saying it over and over again. Can we do it? Is there a way to do it? How else can we do it? And that's where we get into critical thinking. What's another way to do it? Like thinking, it's kind of like thinking outside of the box, but within it. Like you know where your constraints are. You just need to figure out how to build it, right? Everything fits somehow. There's a pattern to everything in math. We just got to figure out what the pattern is. And I believe that in adding and subtracting, we don't teach the children the pattern yet, which is sad. We don't teach them how to do patterns like how to plus a 4, how to add a 5, how to add a 3. Thank you for the hearts. Yeah. Yeah, now I can completely philosophize now. But that's what it is. And these are just like ramblings. Maybe I should like make it into a blog post. My ramblings. Okay. So, that's amazing. Really? Thank you. I appreciate it. What? That it's Tetris? That you just need to know the basics. These are the basics. You just need to know how to make a 3. 2 ways. 3 ways. Is there enough? Can you add the 5? Can you plus a 10? That's it. That's it. That's the secret. That's the secret to adding and subtracting. This is it. This is the secret right here. Nothing else. Whew. All right. Thank you so much, everybody, for the hearts. And wow, I've been on for a little bit. Apparently, I can talk. 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 I've got some sound bites. I'm gonna add in the abracadabra abacus pretty soon. Abracadabra abacus. Yeah. Thank you, magician teacher. Yeah. You're welcome. You're welcome. I appreciate the we could listen to you all day. You make it sound fun. You know, my kids will beg to differ. They find me very annoying. uh but no, I appreciate that. I do. I do appreciate the comments and the companionship and the insights. It's very I appreciate it. Thank you guys. I do appreciate it. And I always find it a joy to talk to people. That's a mom's job. Yeah. Yeah. I do appreciate all the comments and the questions, because the biggest thing is the questions, right? Because if you never ask the questions, I'll never know how to make it better. So that's why it's great that Dolce keeps asking, because it's like there's got to be a way for it to click. There's always a way. We just got to figure it out. That's all. So I'm hoping Dolce that makes sense. I don't know if the word trading like makes sense to you. Um but I think that might be that might be it, right? What we're doing is we're trading it in. And I think it happens to do a you're not annoying. I'm annoyed I didn't learn this already. Yeah, it's amazing on how like abacus makes it so easy. It's just amazing. Um but I do live vicariously through my kids because they have a they can, work their way around their numbers and stuff. And so then they can have more mental power to like figuring out calculus, right? Because this is not about calculus. We don't do geometry, we don't do like advanced algebra, but we lay the groundwork of all that stuff, right? Just as Kat has mentioned, we lay the groundwork of like um substituting and doing a little bit of algebra stuff. So, okay. Wow. I've been on for a little bit. I've been on for like 2 hours and 40 minutes now. Oh, thank you guys so much for the hearts. Thank you guys. I appreciate that. But I no, but you know what? I do appreciate all the comments and the compliments and the questions because that really helps me hone in better on how to explain it. For sure, for sure, and it's easier. It's easier when we get there, right? If there's a mental block, there's always a way to go around it. If that makes sense. I don't know if that makes sense, but now I think I'm just kind of babbling. But I do appreciate it. Okay. But I should sign off. I'm going to rest up a little bit and then we'll probably try it again. We'll see. I got to see what my kids are doing. All right. So if there's no other questions, before we sign off, is there any more like questions that we want to, everyone's questions help everyone? Yes. Yes. Everyone's questions help everyone else. Yeah. Yeah. Thank you guys. Thank you guys. I thank you guys again for joining. Um, see you later, Kat. I'll see you guys in my next live. If there's no other burning questions, I will see you in my next live. And I'm live pretty often. Everybody who's come on board has been vouching for that, except for Dolce. We kind of missed each other, but for the most part, I'm on almost daily, if not twice a day. It just depends. It just depends on how long I talk for, right? So I appreciate everybody. But let me know if you have any questions. If not, I will see you guys in my next live. Have a good day, everybody. Have a good day. And enjoy your life. Enjoy the moments. Enjoy the moments that you have with people. This is not just the only place, right? It cannot just be the internet. So thank you again for everybody joining, and I will see you guys all in my next live. Toodaloo, kangaroo. Thank you, Enrique. Yes, thank you. Have a good day.